We still have morning, yeah? No, it's noon. Good noon. Okay. So, welcome to the Faculty of Architecture of the Technical University in Bialystok. Thank you for coming. You, dear foreign guests, colleagues from our faculty, and any other and sponsors, and any other external guests, and also representatives from other universities in Poland. I would also like to thank you for coming. Thank you for sharing your knowledge and for your will to share your research, share your experiences, share your questions. I think that we'll have also time for discussion during or after the presentations within the scheme of the conference. I would like also to welcome Vice Rector for Science of the Bialystok University of Technology, Professor Marek Krętowski, and I hope he will say a few words to welcome us.
Thank you. Dear participants, on behalf of our rector, Professor Marta Kosior-Kasberuk, I would like to welcome you warmly here. I hope you will have a great conference, and also you will find a little bit time to visit our university and our town. Probably the weather is not the best at the moment, but hopefully maybe tomorrow you will see sun and you will have possibility to profit and to see something also on the level on, we can say, touristic. So one more time, I wish you a nice stay here and fruitful conference. Thank you.
And I also was asked by Alexander Hasanovich to say hello to you. His flu got worse, so he's really in bed, and he apologizes to not join us today, but he asked me to wave a hand towards you, so he's with us. One more thing which I mentioned just before is the different link for transmission. I sent you this new link to your emails accounts. So if you have it, please share it with your colleagues, and I'm really sorry for that. Things happen, and this happened. So yeah, all right. I would like to invite Wolfgang and welcome him here on the stage. Wolfgang is our first keynote speaker. He's an old friend and a professor from the Technical University of Graz in Austria, and he will talk about evaluating the past and predicting the future.
Okay. Thank you, Adam, and congratulations that you finally made it to have this conference happen, which wasn't easy in times like that. And okay. Okay, this is the one thing. So I hope that not too many things will happen through my presentation, but we'll see. I think I have too much to show. and too much text and maybe a rather old-fashioned presentation, but you just have to stop me if it's taking too long and you're afraid to lose your lunchtime. So I start with Winston Churchill. Is always good when you talk about sports or when you talk about architecture, because I think that's a very true quote from him. We shape our buildings and thereafter they shape us. And one of the reasons is that we spend most of our time either indoors or in cars, and less time in nature, I would say, what we have to experience. Sorry, the resolution isn't perfect, but I hope you can read it also on the back. Okay, that's fine. So as you can see, I have the same color of hair like Adam, so we're in this business already quite some time. And I'm teaching architecture, urban design, and digital architecture now for 30 years. Yeah. So this conference on digital architectural research is a good opportunity to look back and forth, and therefore the title I did choose for this keynote. So thanks for inviting, and I will start introducing myself a little bit because my background is architecture and urban design, and I come from Graz. And Graz is quite a special place for architecture, or I have to say was a special place for architecture, because we are definitely less good than we have been. Some of you might know the Graz School of Architecture. Anyone? At least Adam, yeah, okay. The more experienced people in the front rows. So you can have a look. Graz School of Architecture was very, very early and very experimental, yeah. And things like that, all of that was done without the computer. So these are all examples not built in Graz. Only one of this is built in Graz, but it's from Günther Domenik, which is one of our most famous architects representing this kind of work. And this is the only there's a pointer also, I guess. Yeah, this is the only non-Domenik project here. That's Plotek, but I will come to that later. So you probably all know this, because that's an, quite famous building. It is a rather strange building for exhibiting art, I have to say, but it has brought the Bilbao effect. So it's one of these iconic things that brought maybe Graz even better on the map. Funnily enough, it's not from an architect of the Graz School of Architecture, but it's very much in its spirit, because Peter Cook and Colin Fournier, who did it, so it's more or less the first building they built, Archie Graham, in reality, and also the Moor Island. So these are some other examples that you can see from Graz architecture, and you don't really see probably this building to the right side, which is a university building that I will come back to it later, because Plotek also did a competition design for that, where I will talk a little bit about it. And there's a funny story about this, because one of my student teachers, student assistant, who was early involved in Lisp programming and stuff like that, he was working on this project, and it's a 400-meter university building, and they did routines in Lisp and AutoLisp for AutoCAD, and they had a rounding error somewhere on the 7th part behind the comma, and that ended up that after 400 meters, the columns were 30 centimeters away, where they shouldn't have been. So that's another story. So, do you know anyone from Graz? If you don't know the buildings, do you know people from Graz? Besides me? Yeah, yet. Okay, there are quite famous ones. Ha! The funny thing is this sheet is rather old. I showed it several times. And for example, in China, they don't know him anymore. So also Terminator fame is terminating, I have to say. The most interesting picture, more or less, is the one to the right, because he really managed to become governor of California, which is, yeah, I think a little bit higher population than Poland. So, yeah, so it's pretty similar, I would say. And what do? I teach, naturally, working at university. I teach in Graz and also for a long time in Hong Kong. And I teach architecture and urban design. And my main research areas in the early times were about city modeling. And now I'm interested in virtual reality. And you can see I had several jobs through university and in Austria. So most of them are now former. Because as you can see, I'm trying to get rid of the non-former parts. So in March, also the first one here will become former. And the only thing I will stay on is probably the coordinator of this network where we work, TU Graz has together with Asian countries. Okay, and why am I standing here? Because I somehow stumbled into computer-aided design. When I started at university, that was '92, I was more or less the only person who ever already worked with the computer in architecture. I did my final thesis in architecture already writing with the computer and using him for special tasks also in the process. And so I ended up in the beginning to have courses. We had 17 courses for introduction into CAD that I had to do with students because I didn't know all the programs. So I gave the overview of the principles and stuff like that. And then we had 17 different courses to bring them some ideas how to use this new medium. And at that time, there was a much bigger variety of programs. These days, there are very established programs. Yeah, but at that time, even from Graz, we had 2 different CAD systems that were developed in Graz at that point. And one was a super perfect system, but it was just too early for its time. So it was too good for the computers of that time. And that was quite a big problem. I'm probably talking too much, so let's skip all that. And I used several different presentations to get you into the mood. And the first one is that I tried to use some quotes from the Atlas of Digital Architecture. I don't know if any of you have already seen that. That's more or less a concept that we did in AKI, that is the Arbeitskreis Architekturinformatik, which is more or less the teachers who are involved in architecture and CAD in the German-speaking world. And I'm one of the founding members of that. And Ludger Hovestad, together with Oliver Fritz and Urs Hirschberg, edited this book. And it became quite an interesting concept because the main text was written by a person who is not involved in architecture and not involved in any technical issues. He's a writer. So he had to do interviews with the people and then write about it. And therefore, he came up with some quite interesting statements, I would say. So let's go through them, or through the important ones. I have to be a bit careful not to give you sound problems. So in the introduction of this atlas, he was referring to the fact that we at the moment have a lot of images, indexes, and references. Everything is getting more and more, yeah? So, and digitality is omnipresent, as we can see. I'm pretty sure that nobody is here without any digital equipment. And probably you all used it quite a lot during the day already. And one of the statements here is in the introduction, the real challenge today is not that things are becoming more complicated with computers, but rather that they are becoming extraordinarily simple. We can discuss that, I would say. This is exactly why they are so successful. With their intuitive, easy interfaces, it is not us who understands computers any longer, it's computers that understands us. As I'm called quite often when something is not working and the computer is not understanding the person who is trying to use it, I'm a little bit of doubt if the computer always understands us. But we'll see what's going on with that. Okay, and Sebastian Michel, who wrote this, more or less then went on in saying that, okay, you could argue that these days everything is too much that we have in this sector. There's too much information, too much design, too much of everything, and too much speed, yeah? And what I found quite interesting as an introduction and final sentence in this is what's written down here. Everything is happening too fast for us, and everything has started to look the same. Our architecture, our cities, our environments. That's a pretty depressing statement, I would say. So let's forget about computers and go back somehow. That means. Okay, so as already, this quote about being more simple or less simple is maybe true in a way. When you create content for your smartphone now, it's totally easy, everyone is doing that. But when I think of students doing their designs, I'm pretty sure that we're not there, yeah? So it's not that it's now so much easier to design because we have computers on an average level, I would say. Somehow my colleagues who are into teaching digital things in architecture, they forget that they most of the time work with rather experienced students that already have a certain experience on that, and they can do quite proper things. Also those kind of iconic buildings. But every architecture matters, I think. So not only the great things that we all see from these glossy magazines, or that's the reason why we travel to Bialystok or to Warsaw or somewhere else to visit architecture, but because of other reasons. And I think, okay, I think it's still not the right, okay, I changed a little bit, but doesn't matter. So the building sector and with it architecture has a global impact on many aspects. First of all, as already mentioned, we spent a lot of time indoors. So it really makes a difference how this environment is working. And the next thing is that is a big business. Building sector, architecture with it is big business, because 6% of global economy is more or less based on this industry. And we use a lot of energy, 36% of energy consumption, and nearly 40% of the global CO2 emissions are based on what we do, more or less. And United Nations predicts that the world building stock will even double to 2050. I maybe hope that this won't happen, but okay. And all of that, the whole concept of digitalization in building gives different concepts, yeah? There are, is there any? No. Under this general digital transformation, there are, let's say, different things that you can understand with it. And they more or less go far beyond the transformation of analog information into digital formats that was in the beginning of the whole thing. You probably all heard about Mario Carpo and his second digital turning point book. Any one of you have read that or have seen? Okay, so some. And he already proposed in this second digital turn that architecture managed to create new building worlds based on the use of this large amount of data that we have available and the ability of the computers to filter this data and from it equally create virtual or physical buildings. So, and also Ludger Hovestad already wrote in 2008, of course, such processes can no longer be controlled by hand, but only with the computer, because any local change of a single element has a global impact on the system as whole. And I think he's right. And with artificial intelligence, where we are on the brink of establishing that also in our profession, we probably lack the intelligence to control the computer, even when we use a computer, because we don't know what's going on inside. So, and I think also this digital transformation of the architecture, and the construction industry is a challenge not only of our profession, but also of whole humanity, you can say. So the increase of productivity in the construction industry is maybe concentrated on the industry, but the rest, climate neutrality, waste reduction, disaster resilience, and high quality and yet affordable housing, they affect all of us. So what you will do in the future will affect a lot of people. So I think I'll skip that. I go to the last thing, because I use, for this kind of statements, I use a quite interesting little essay that Katrin Braun and Gordula Kropp wrote in German. It's called Schöne neue Bauwelt. And they already more or less say that we are facing 4 different scenarios of these future worlds. Okay, and it's the wrong presentation somehow. Because I did sharpen it a bit. Okay, I wonder why that happened. Okay, but let's see. These should be 4 slides now, so it's not so easy for you to see it here. So the first of these 4 maybe different future worlds in building is one that is more or less focused on automation and productivity. So it's bringing architecture towards car industry. So we want to have streamlined products, streamlined, shiny products with high efficiency. And the next one would be a more integrated oriented guiding principle, where all these technologies try to overcome all the fragmentation we have in our processes. And that's more or less the BIM aspect of this future digitized architectural world. And then there's the so-called schöne singularisierte Bauwelt. That sounds rather strange a little bit, but it's the, let's say, the world where digital means help us to do this special things, to do Bilbao, let's say. Special things have always been possible because special architects could always do special things, but things changed with the possibilities to also build them. So I think that's one of these future worlds. And then maybe one of the really, really most important parts of this future building world would be the sustainable building world, because if we go on doing buildings without thinking about sustainability, we will run into one of these walls pretty quick, I guess. So, man, that's the world where the digital sustainability comes into. So where the computer-based technologies help us to build buildings with fewer resources, less waste, and fewer emissions and fewer energy. Yeah, and you all probably have heard about concrete consumption in the world, that China used more or less the same amount of concrete in very, very short time that the US built in 100 years. So, and things like that clearly shows that we cannot go on like we did for a long time. But with all those kind of possibilities that we now have, yeah, with, let's say, that the planning now doesn't only follow the geometry of a designs, but also an underlying logic and underlying other processes like calculation and optimized versions. And you can discuss with the computers what is the best solution in terms of several aspects. Yeah, the computer will always be able to tell you, okay, this design is better in this and this and this and this aspects. But it won't really tell you if it's better architecture. That's a different story. Because everything else can be planned pretty clear. But the question sometimes really is, where is the architecture in that? Yeah? And as being a teacher in architecture and urban design, you're always facing with this problem. Yeah? Because everything starts with the design of an architecture. Yeah? In fact, architecture begins with an idea. I think you probably cannot read that, so I have to tell you that's from 101 Things I Learned in Architectural School. Matthew Frederick, you probably all know the book, the students at least, I guess. So it's a nice little book who talks about important aspects when you do design. So everything starts with the idea, yes, but sometimes before the idea, you even have to find an idea of for a certain task, because you quite often get the task and then you have to find the idea, okay? So that's an important thing. And then what my students tend to forget is maybe good described with this quote from Louis Kahn, that architecture is the thoughtful making of space. And after many years of teaching, I just realized that students quite often don't understand space anymore, or even less than they understood it before computers. And that's really strange, because that's the opposite of what we expected to happen with all those digital tools. But still, at the moment, young students, at least in our case, they more or less tend to think that architecture is about making proper 2D plans. If you have a proper 2D plans, you have a proper architecture. So, and I very much doubt this, and we will come back when we talk a little bit about artificial intelligence. So, I think in a presentation about past and future of architecture, the name Tom Maver has to be mentioned, and I guess on Friday we will hear again his name, or even tomorrow, okay? On Friday also. So he's one of our pioneers, professor in Glasgow and director of Abacus there, as long as it existed. And he was a pioneer in the field, and he addressed design as the highest endeavor to which man and woman can aspire. Not totally correct. These days it would have to have women and men, but that's another story. And there is also 60 years ago that E.Hjelseth showed and talked about the director-agent model of interaction. Any one of you familiar with that? I was a little bit unsure if I should mention all those old stuff, but then I thought there will be a lot of young people in the audience and they might not even know some of it. But you probably heard about Sketchpad, I think, or? Okay, because I will do a little look into that. And you definitely heard about Franco Gehry and Bilbao and so on, which more or less changed the world from, or the term CAD from computer-aided drafting towards computer-aided design, in a way. So this is Tom Maver, who in 1977, quite some time ago, already started and tried to explain the benefits of using computer-aided design. And this was also the page where he more or less said that design is this highest endeavor. Yeah? And he wrote this very short paper more or less as an answer to another paper who was criticizing these new stuff, this computer stuff. Yeah, and we all know, as we started, a lot of our colleagues in architecture were the same opinion. For a long time at my university, professors didn't accept computer plans, stuff like that. So it's another world there. So, but let's talk shortly about E.Hjelseth's typology of the director-agent model. He was Russian, and he theorized about how this process of interaction with the machine is going on. And I think this sketch really shows quite a lot. There is a lot of thinking going on in the designer, which then ends up, let's say, in an information you communicate to the machine, and the machine is more or less a black box who does something inside, yeah, and has two portals, one in and one out, yeah, and so you, the designer, have to be creative. You have to do creative ideas and then try to give these ideas to the computer quite simplified so that the machine can do something with it. And once there is this calculation done in the machine, out comes something of the black box. And when you are lucky, then this outcome helps you with your creativity. That was the principal system of this typology. And funnily enough, most of the things that we still use when we interact with the computer are still more or less based on all these kind of models. So we still use command line to put in commands. We use the mouse, and we do maybe use a script editor. And they are pretty good, those kind of possibilities to talk with the computers perfectly when the computer should do a very specific task. Yeah, so that's okay, and when you know what you expect from the computer. What's less good is when the whole objective is more ambiguous. So, and that's what the process of design normally is. Yeah, so this whole model breaks a little bit down because you cannot give concrete commands to the computer besides telling me, do me a house. So that's maybe in the future. But if you don't know what to ask the computer and what the computer will be capable of doing and helping you, then this system didn't work. And the machine's usefulness is more or less limited to what you can think and create. Artificial intelligence these days are changing this, yeah? Because now this black box is also beginning to think. The big problem will be, from my point of view, artificial intelligence can only be as good as what it learned and from whom it learned. So I think there is a big field on that, and I don't know if some of you are working in this field, but it will be interesting about the outcome of these kind of systems. Because really, I think it's very essential how the whole artificial intelligence will be trained. And I have a certain fear that the hard facts are much easier to train. So what is efficient, what is cost effective, and what is that? So I wonder if we really become more interesting or better architecture, maybe better architecture in certain performance criteria. And that's maybe also something that's quite good. Okay, that was the model from E.Hjelseth, and now I do a short glimpse into Sketchpad, because Sketchpad, although many of you probably know that Sketchpad was the early thing where first drawing lines on computers, there is more to Sketchpad than that, yeah? Because that interface that Ivan Sutherland developed was composed more or less of two separate things. The one was this light pen, where he could tell the machine, okay, to do lines. And the other one was a dock of push buttons, where he can use certain or activate certain restraints in the system. And with that, he managed more or less to do the complex code of the whole program in a user-friendly way, because you could just tell the computer something, and the computer could then trigger that. So you could directly manipulate without writing code. And that was very different to before, because before you had to write any code when you wanted to have something on the screen. So that's how this thing looked like. And the interesting thing is that there is also a layer of topological intelligence in Sketchpad graphic objects embedded. And you could activate different things of that. I won't go too much into detail, but the important thing is that you could use these design constraints that you these days do with, let's say, using snap functions or thing like that. Yeah, he had built that in to be used afterwards, because that was a different system. So you could draw something rather sketchy, therefore Sketchpad, but with certain additional orders, you can tell the machine to do something similar. Similar but more precise, let's say. So you could begin with a vague idea what it should be, and then add these constraints. As an example is this, quite famous. He shows the sketch of a rivet or something similar, but he draws it like that, and then uses constraints that the outcome is like that. Okay, I think I'll hop to that. How far are we in timing?
It's 33 minutes has gone.
Okay, I have to hurry up. Okay, many things that were developed then, we still use them now. So that was one of the first graphical user interfaces, also this object-oriented programming, and the computer-aided design aspect. Everything was based on that. So therefore, I thought it would be good to remind you about Sutherland and Sketchpad. And as mentioned before, a lot of the things we now use in much more refined versions are still more or less versions of all these things that we were established then. And that's 60 years ago. So we can say pretty slow movement in creating new stuff. So I think I already talked about that. Now the black box is also thinking. So, but I want to talk a little bit about design. Direct conference is called about digital architecture research, but I think research cannot ignore design. So, and design is one of the big basis for good architectures. And the big question that all students always have when they start to become architects, how do I get this bloody idea? So how do I find what inspires us to do something and to do something new? Yeah, and that might be a challenge always, not to do something that maybe was already here 30 years ago, but nobody knows about it anymore. But you have to be experimental. And that was one of the reasons why, for example, Graz School of Architecture had so many exciting results, because they experimented a lot. And a lot of that didn't work out. So in many reasons, some of it failed enormously, but it was always interesting. And that's one thing. And I think I like, and I have to remind you of this aspect of creativity that's inevitably embedded in the whole system. If you are not prepared to be wrong, you never will come up with anything original. If you always, as an architect, work on the safe side, then I can give you a past, maybe, yes? You survived the course, and maybe you will be able to build some architecture, but it won't be anything really significant, which is not all that bad as long as you manage to fulfill other aspects, let's say. So it doesn't always have to be the iconic buildings. When it's a sustainable building, it's also great. And maybe that's even more important for our future than those few iconic buildings. But still, it would be great if you manage in your career to create both the exciting and sustainable architecture. So, and now I come to one of the pioneers on the Austrian part of these, how to become an idea and how does a computer help you to become ideas. Also in Bialystok, a lot of people worked on this topic, but I thought I introduce Manfred Wolf-Plottek and his early ideas on how to use computers. I'm recorded, so I'm not allowed to say that I didn't like him that much, but he was very interesting in his first attempts. So he started in doing morphing experiences in the early time. And as he has a little artistic vein, let's say. So, and very much in the spirit of Graz School of Architecture at that time, to be experimental and maybe shocking and everything you could do, because we are not Vienna. So you could do much more stupid things. So he started to morph a cow and a house. So, and wanted to come up with a result that he could then use for designing the house. Yeah? And he added that. You can see some other morphings going on from this cow house, and it's a house for people, not for cows, but that was one of the early two-dimensional things that happened. Or, for example, he morphed Le Corbusier with a chair, and ended up with a chair, yeah, with a different chair, yeah. And to the right, he called it seziertes Haus, dissected house in stripes. So he morphed a plan, a floor plan, with the topography lines. And then ended up that the morphing ended up in a rather strange house compared to the original one. But he used that as his inspirations. Okay, it's really the old version of my presentation here, because I wrote this a little bit bigger, so you probably cannot read that behind the third line. So I will read it for you. This was more or less an urban design project where he used a mistake in the AutoCAD Hedge command, because Hedge did produce very special things in the early AutoCAD versions. Adam is agreeing. When the polyline wasn't closed properly, it made a total fuss out of the hatching. So, and he used that to create an urban site plan. Yeah. The problem with Plottek is that sometimes he's taking the whole thing too seriously. Although he's joking all the time, because the last statement down there, you probably cannot read that, is, I read it in German, zum leichteren Verständnis in der Ablesbarkeit durch noch gängige Sehgewohnheiten und für eine angenehme Wohnqualität erhält jede Wohnung eine eigene Eingangstüre. So you don't speak German, so I translate it for you as a special treat for people who are used to old ways. Every flat has an entrance door. So he allows you to enter the flat. The problem with this with Plotek and this kind of projects is that he did build houses like that. And in Seiersberg, where he did this building plan, he built a house where all the angles are 94 degrees. Because the computer told him 94 degrees would be the right thing. And they have a high turnover because people were, it's a rather clever floor plan, I have to say. So it's not a bad architectural design. But it would have been even greater if he would have stayed with the 90 degrees, because then people wouldn't have needed special furniture to equip their flats. So, and he did, okay, and that's a little bit problem because I dropped a lot of that and highlighted the most important things in the last version of my presentation. But he did also join in the competition for this 400-meter university building that I showed you at the beginning. Yeah, and he said the interesting thing was that the brief said it would be enormous amount of rooms of similar or the same square meters. Yeah, because university buildings, you know, professors get that many square meters, secretaries get that many square meters, students get that many square meters. So they had the brief very much detailed on 500 rooms with several different room sizes. And because he was already working with the computers, he decided, okay, I'm not doing that manually. So let's see what comes out when I feed the computer with this. And he was a little bit complaining that these days you cannot tell the CPU to design a university with the command design a university. But we might be getting there, but let's see. So he used all that, and then he did different solutions how to work with these 500 rooms, how to orient them, how to rotate them, and the whole thing came up with things like that. And then naturally he found out there is a lot of overlap because he allowed rotation and stuff like that. And that's a little bit complicated when you have overlapping rooms in 2D. So naturally this had to become an idea in 3D. So he had to shift levels to make it work. And naturally he also came up with room sizes that were not really usable. So the 40-meter room with 1.5 meter width and stuff like that. So anyway, I'm not using too much time, but what he really also experimented at that time, that was 85, was how to really work with the computer to get an idea for such a complex project, let's say. Okay, and that's how he then ended up, and like Gary, also a lot is then has to be translated into models to have a look if it works or not works. And he goes on here that there are several things that were unexpected, so that were more or less accidents, like the hedge command in AutoCAD, and that he used more or less then as a design issue. Okay, I won't go into that. You all know about Frank Gehry. Let's go back to designing. Yeah, how do we do architectural design? Okay, it's a pity that's not the highlight version. Okay, in the past, sketching was the thing how you design. Yeah? How do you design? I'm not biting. How do you design? You're designing architecture, or? Yes, who is designing architecture? Here. Okay, how do you design? I'm not biting.
Well, I use many different tools. I usually start with sketching, then I use
okay.
the greatest
So you're a perfect example for what I once wrote in a paper. What is important is to use the right tool at the right time. Yeah. So, but sketching is still an issue, in a way, or not? Anyone not agreeing with that? Yes, it's still one part of the design process in an early design. Yes, of course. Yes, of course. Okay. So, and I also think that it is. And the pity is that, for example, in our university, I don't know how it is in your university, nobody is teaching sketching anymore. So we don't teach our students one of the most important things that is still important, also in digital times, to use as a right tool at the right time. And for me, that's really an issue, because sketching has still its advantages. And it doesn't matter if you sketch on an iPad or digitally or manually, that depends on what you are used to. But to bring ideas in this sketchy phase is just very important. And at the beginning, when I remember, at the beginning of these kind of conferences and so on, there was a lot going on in terms of how can we sketch with the computer? So, and how can the computer understand a sketch and then create what we, or even put further what we tried to express with the sketch, which is a tricky business because a lot what you do in the sketch is in your mind and not in the sketch. So it's tricky that the computer should understand what you are thinking about it. So when you look in Kumminkat, and I think many of you know Kumminkat, or who doesn't know Kumminkat? Okay, have a look. It will help you. It's one thing that we established at EKD, together with all the siblings organization. It's a cumulative index about publications in our field. So you will find a lot of work for your work already, aspects of it in this on this site. So just Google Kumminkat. Thanks to Google, I don't have to give you the link. So you will find it. So I was a bit surprised when I did the search for sketching that I did only find 248 results in sketching. And modeling more or less had it 10 times more, but that's maybe because there are also other aspects than this kind. So, but in fact, everything boils down to two things: the idea generation and the idea development. Yeah, and here I found something quite interesting from a paper where John Giro was involved and Zafer Bilda, and they tried to find out if sketching is really essential for designing. Yeah, and what they did was that they picked 6 experienced designers, and they let them do design ideas when they were blindfolded and not allowed to sketch, which is did you know about this kind of? So it's quite an interesting idea how to check out. And the interesting thing was that these experienced architects really managed to come up with solutions when they were not allowed to sketch. But I will state that this was only possible because they are experienced designers and because they know how to sketch and how to develop architectural ideas. It's definitely not possible for a student who is starting in design. So you need to have a certain minimum of experience to really not use sketching, let's say. So, but for me, that was quite an interesting result in this research. But in fact, it doesn't change the fact that we need to teach our students also all the tools that are available. And I think we don't do that anymore, because neither do we really. That's the last of the statements, what they said in this paper. Students learn how to progress their ideas through sketching. Okay, nice. The paper is, I think, 12 years old or something like that, 2008, but hasn't really changed at all. As I already said, we don't teach sketching anymore. And we also don't teach computers that much anymore. How to design with computers in our university, that's not really an issue for bachelors, for example. It's maybe just scratched a little bit. But for me, the problem is these days that young students, they more or less, when you tell them they should start with sketching and stuff like that, they do it with the computers, try to do it with the computers, with less good results when they would have done it without the computer. Yeah, and when you talk with them, they're doing it with the computers because it's clear in the end, the whole thing has to be in the computer. So it's wasted time if you don't use the computer from scratch and from the beginning. So that ends sometime really in disaster. And it's really rather frustrating and strange that after, let's say, 25 years of computers in architecture at universities, you still have students, like I had last semester, who more or less did design what they could draw on the computer. Yeah, and that's a rather depressing thing. And I already mentioned that some of you who are really teaching in the digital design world, when you work with those few experienced students that are already in the field, then you can really end up with very interesting results because they are capable of doing so. But there are a lot before where I'm really a little bit worried about the quality of their designs because, as I mentioned before, we found out that they don't understand their spaces anymore. Less good than they had. And that's really very far away from this increased design quality that Tom Maver was talking about 45 years ago. And all these aspects that we had here, I won't go into detail of that. So I think I'll go on with Tom Maver's statement also where he cited John Lansdowne about predicting the past and remembering the future, that the future will be just like the past, only more so. So it's quite nice, but we'll see if that will be the truth. He already then said, you remember that was 77, we need to be able to design from within the virtual world. And that's one thing that we're talking about when we try to bring the students to have more ideas about their own design and about the spaces they create, and not only the plans they draw, then we now have, let's say, new means, because there are new developments, and virtual reality in its new version offers new possibilities for that. We're still not there, and virtual reality is an old thing, yeah. As you can see, I think I already talked about that. Okay, you have to understand your space. It doesn't matter if you use sketching or if you use digital tools. But in the end, you have to create architecture that is working and that has fulfill a certain ambition if you're a designer. And I have this sketch in here because, do you know this architecture? Yeah, okay. So, and do you know the architect? Hans Hollein. And Hans Hollein was, I don't really like his architecture that much because to me he's too much postmodern and stuff like that. But what he really was, he was a guy, I know people that worked with him, he could really talk about the space from a sketch and more or less explain every aspect of the 3D concept of this sketch. So he really understand and could explain about his spaces in a very early thing. And therefore he created some really interesting spaces. I don't like his outside things so much, but he has several projects where he has really great interior spaces. So that's already mentioned, okay, that we sometimes now have the problem that the designers don't understand their own design, and then they end up with things like that. There was something wrong, like you mentioned at the beginning, things happen. So happens also to designers. And things happen also when you use, obviously, probably the computer. That's a picture I took in Croatia. 5 minutes, okay. I'll hop on. So I think I wanted to do a short thing onto VR, but I will skip most of it because you probably all have your own experience about that. So VR was on the menu for a long, long time, but it always was too expensive and too complex to be used in the design process. It was used, okay, for Boeing and big companies that had the money, but not for architects. And when you asked architects, years ago, we did a questionnaire on Styrian and English architects, and nobody used any of these. We were happy when they even used computer tools at that time. But already 20 years ago, a guy called Henry Achten worked with VR in the design process. And he established at that time the rules. How is it called? Only do? To be fair, not me, Bauke de Vries. You and Bauke, I wrote it down here, and also Jesuran. So you were involved in the whole thing. And that was one of the first things I experienced, because I stumbled over it and I experimented with it when it came out, because it was open for universities. We could use it. And that was more or less, maybe you should already go on presenting that, but I have only 4 minutes left. So it was to design in VR. And I just show you the picture. I don't go into detail of that. But all these things that were established then, that it should have a simple user interface. It should have an easy way to create in a VR environment, and you should easily be able to manipulate this environment, and the navigation in this world should be great. That's still an issue that we are talking about and researching about many, many years after tools. So, and that was how you could work with tools. So you could create this kind of blocks and do them around curves and get ideas for architecture. And maybe you should have made out a game out of tools, because as you remember, you can be quite successful with games that use these kind of blocks and create things. So, and therefore I'm still interested in some of the research I do at the moment is to still do things like that after many years later, because now everything is much more affordable, because the gaming industry went into these head-mounted displays, and you all have experienced that. And the only thing is, there are still only a few things where you can use that to create architecture, because you still are missing certain functionalities to really use it. There are already some apps that are working with that, but there is still not enough, and still a little bit too complicated for a certain design idea. So I skip over, because these are more or less our things that we developed in doing that, with using Google headphones, and we came up with that the only good things to use that would be to have this annoying clicking on the head for moving replaced by just walking. And we did that with wiring up our students like that, as you can see. And it was really, really funny how much more feeling of immersion that gave when you could walk in the virtual world. And we also tried it to implement it on a bicycle, so because I'm also urban designer, so we want to cycle through our urban projects, and that's what so ended up doing quite nice-looking concepts for Google. 1 minute, I'll squeeze through. And that's what we do at the moment. So I skip all that. I don't show you that. That's one of the projects that we developed. You can walk through this world, and then it will create an exhibition between that. I can start it for, let's say, just one example. So between those columns, you can then create the... Okay. Oops, I went out, but I have an important slide to show still. Sorry. Because I wanted to show you that in terms of this kind of inspiration from the computer for architectural design, Bialystok University was also already very, very early in organizing conferences on that. There was a conference in Bialystok in '97, which was called CAD Towards New Design Conventions. And there were a lot of impact from Alexander, who already waved to you at the beginning, and from Adam, who was doing the waving for Alexander. So, and the last thing, I won't go into detail, I think that should be my more or less last slide. Artificial intelligence and architecture will be one thing that you will hear about quite a lot. And I'm not so sure if everything we will hear about that will be really good. Because already you can go and have, let's say, a basic free plan. You can have 3 projects, unlimited floor plan options. You can order for free. But when you look at that, everything looks like it's a floor plan generation. So that's not architecture, because architecture is 3D. So, and floor plans are the easiest thing in all of that. So I'll stop with that. As I said, I have certain doubts if we will end up with better designs. Maybe some of those iconic designs, yeah. But maybe, okay, in those aspects of sustainability and streamlined process and BIM, we will have quite good development. In terms of design, I'm not so exactly sure. So I remind you about what I wrote some time ago, this use the right tool at the right time. And what sometimes students do is trying to use the wrong tool at the wrong time. And that costs an enormous amount of time and brings you nowhere. Because as you all know, in architectural design, a lot of it is more or less just to understand why things don't work. Yeah, and why you cannot do it that way. So, the final quote from Tom 20 years ago is still okay. What is certain is that the next 30 years will be every bit as exciting and challenging as the first 30 years. And as I mentioned, I'm putting forma on all of my jobs, so it's up to you now to create the architecture within the next 30 years. Thank you for your attention. If you have any questions or comment, just contact me. I think I stayed quite in time. Oh, perfect. Okay, thanks.
Well, I think since we have quite a lot of time for lunch, we can have at least one question now, if there is any question from the audience.
Where is lunch?
Just over there. Yeah. Yep.
No, we can talk at lunch.
Yes, you can. Yep. So the lunch is in the room, which is just behind the door here. And if you, maybe you may wonder where the restrooms are. So there are right diagonal of the big hall, just near the stairs. You'll find when you go to the this corner of the big hall, you'll find it. Okay? Okay, so now we have time for lunch. Thank you, Wolfgang.
2. O, raz. Próba, próba.
Próba, próba. Test, 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 test. Tu, a. Próba, test, 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 test. Test. Raz. 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 Dwa. Raz. Dwa. 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 Musiałbym...
So, welcome to our first session this afternoon. We will have 3 presentations. I would like the first presenter to come forward. It's about the topic, nice title by the way, Smart Code, Shape Up or Ship Out. And it's from, I don't know, I had no time to ask you how to pronounce you correctly, so you should do that.
My name is Ayça.
Ayça. So it's Ayça now. Okay.
Thank you so much. Thank you very much. It's a pleasure to be here. Before my presentation, I would like to send all my condolences to the people who passed away during the earthquake in Turkey on 6th of February. And we all thank you to the Poland rescue team and the Poland government for your support and help. Today I'm going to try to present the study process about smart code, shape up or shipped out. Yes. This research derives its motivation from 3 major factors that influence the form what man has built. The first one is space, which is what we need. The second one is tools, which are ability to communicate the idea. Third one is material, which is around us, and we find the ways of adapting and using it. According to these 3 factors, which were noted by Neil Leach, I would like to add one more factor, the role of an architect, because he is the pioneer of this process. In this context, I would like to start from the first motivation factor, space, because space is the main subject of an architectural design and the main concern of an architect for centuries. Space is all about physical and emotional until the digital era. Our relationship with the physical world was transformed by digital tools. We see with digital cameras, listen to compressed digital files, use AI personal assistants, and experience VR. We live in the world of smartphones, smart buildings, and smart cities. The list of the areas where our relationship with the physical world is transformed by digital tools and media goes on. Reality has flattened, and screens have turned into spaces and spaces of everyday life. Therefore, the traditional architectural space has melted. The second motivation factor is tools. Throughout the history, technological and cultural values of architecture have embodied with materials and tools. Through the process of designing and making, the dialogue between man and material is directly related to the techniques and tools of that period. Tools not only have a dynamic communication between design and construction, but also provide new directions for creation and innovation. Tools have been changed radically in the digital era. Simple design tools such as pens, compasses, and rulers have been replaced by computers in the last 4 decades. Nowadays, 1 and 0s are the new tools. And the third factor is material. The material defines the skin and volume of a building from interior to exterior. 3 traditional materials are exemplified in this slide. Wood to shell, so from circular section to plate, from natural limestone to cement, so from fluidity to rigid, and from sand to glass, so from opaque to transparent. This shows us how natural materials can be transformed into different forms and faces. So the new composite materials should be in the game. And the last factor is architect's role. In the beginning, from Greek tecton to master masons of Middle Ages, they were in charge of all aspects of buildings. They had a central and powerful position in production of buildings. However, the tradition of master builders didn't survive in Renaissance cultural, economical, and social shifts. The use of perspective representations and orthographic drawings became a medium of communicating information about buildings in the Renaissance. The abstraction of plan, section, and elevation has become adequate information to build. In the mid-19th century, drawings of the earlier period became a contract document, and this started to widen the rifts between architecture and construction. In addition to that, general contractors and professional engineers appeared. The authority, The authority they had once was dissolving. However, the lasting legacy is tens of thousands of drawings are required for a medium-sized project. And nowadays, although digital processes represent a radical departure from the normative practices that redefine the relationship between conception and production, still, the role of an architect is not more than a drafting instruction of a building. Architecture should be more than drafting an instruction. If we take our critique of the architect's role further, technological developments of Industry 4.0 and 5.0 have been used in many sectors, such as food production, healthcare, manufacturing, etc. Uber is the largest taxi company with no cars. IBM Watson Computer provides legal advice with 90% accuracy, so in the future, 90% fewer lawyers be. According to the French industrial policy, which includes 34 plans, architecture is not of them. So either we shape up or shipped out. So according to these 4 motivation factors, we have the ability to produce 16 different types of X with different typologies, but we still construct concrete, conventional structure under the amorph shelf. Or we construct very precise details and we can have fully control of the construction process, but we are still building damaged concrete. We are investigating new types of materials in different industries, but we are still selecting conventional materials, concrete and brick. And all these opportunities, we have the ability to think and design a jellyfish project, but we cannot build it either. So the question can be, is another way possible? When we start to look at the examples from the past until now, the main concept is always space. From Crystal Palace to Mobius House, boundaries of a space are dissolved differently. Crystal Palace is all about interior and exterior. The Mobius has no interior and exterior definition. From Fun Palace, movable programmatic volumes had been changing according to the demand of the user. In the Peony Pavilion, the Queen Feng project proposes a new form of theater using the design of special interactive installation, which assesses the relationship between performance, space, and audience. These projects are some examples of architectural space intents, and according to the technology, architects always push the boundaries of spatial perception. When we look at the development of production, technologies open new horizons for us. For example, the prefabricated house of WikiHouse, a very precise and fully controlled digital grotesque by 3D printing, hair-like structure of a Celia project, interactive construction of the communication landscape research project, 3D food printing to the personalized sneakers or 3D printed fluidic wearable design. All these production methods will show us that instead of stereotypical design and construction processes, there are tons of opportunities for digital technologies. It depends on how you design to use it. Nicholas Pevsner noted that painters and sculptors affect our senses by creating patterns, shapes, light and color. But only architects shape the space in which we live and move. These shaped spaces and buildings are conceived, designed, constructed and used as entities. The building is not an assembly of inert construction materials and components, it's a living, embodying human memory, values and actions. The building is a dynamic structure that is constantly adapting to the user needs and presents environmental conditions over a long time frame. To understand the dynamic structure of a building, Stewart Brand proposed shearing layers model. According to shearing model, the building consists of 6 layers. The upper layer, shell or skin, is the most examined part of these layers because facades reveal the prestige of both the building and architect. Combination of these layers are shown in the rainbow matrix. In this color matrix, studies are mostly carried out of the shell. There's a few examples of stuff and space combination, or there's any combination of stuff and service. Or multiple combinations are very limited, like service, structure, and stuff. In addition to all these layers, Smart Code claims that there's another missing layer, which is movable, unpredictable, and ephemeral. It should be a human layer. So where should be located the human layer? In or out of between layers, or it should be between like a snake? According to Arendt, human existing is in two fields. The first is nature, and the second is the non-natural field he created. So how does he produce a non-natural space? The relationship between thinking and making is originally held by the craftsman hand. Craft is work to meet people's material needs that are required experience, skill, and mastery based on learning and teaching. It's a learning process based on handcraft that requires eye and hand coordination. Today, the integration of generative software opens a new type of designer craftsperson. Digital processes require eye-mind coordination of thinking. The design and fabrication processes involves complex cognitive activity that includes the human brain, human body, materials, and environment. In the last decades, human control tools in traditional production systems have transitioned into computer-controlled digital production system. Smart code claims that architects can become the 21st century version of their medieval predecessors and can be able to gain the artisan title again through the digital technologies. Digital craft can be the new medieval discourse in the digital era. Throughout the dissemination of digital modeling tools during the past decades, the ubiquitous representation of the architectural product is surface, facade, and shell, whereas the design and construction of the core or inside are still stereotypical and incompatible with the logic of the shell. Besides digital twin and BIM, which works in traditional relationships of AIC, Smart Code targets to reveal an intertwined system of a design and construction based on close interaction between designer and production and resilient circular conversation. Smart Code forms from inside to outside, from the smallest unit to the larger unit with the human and object interaction. Designing and making process, which is intertwined in the action of artisan hand, because the smaller unit of an architectural space can give us more freedom in design and can allow us to new opportunities in terms of speed, multi-materiality, and reversibility. A new brick of digital era. Sorry. The project will be developed by two opposite production methods, metrology, which is loading, and carving, which is unloading, which are inspired by nature. The first method, metrology, part to whole, part to part, and all these six layers will be merged into a small unit and tested in a created volume. The second method is carving, which works the opposite way of building on top of each other. Unloading can be another way of testing. In this Cappadocia cavern can be a good example of the combination of these layers of shearing model. In this cavern, structure and site was ignored, skin is ignored, space, and services was created when it was needed during the time. Approaching the end of the presentation, I would like to show an example in this slide, which was built in 2022 by Yunga Ishimi architects from Japan. This slide is a good example that makes us to think and question our way of construction again. The site filled with concrete and then started to be carved according to architectural plan. In my research, I'm not talking about carving the rug. I'm just talking that unloading existing small units volume can be a method of construction. And the final slide, I would like to summarize the Smart Code aims and claims. Smart Code is not a shell design. It consists of combined 6 layers of shearing diagram, and it's triggered by the new architectural space of Industry 5.0, Society 5.0, and Architecture 5.0. Smart Code forms from inside to outside, from the smallest unit to the larger unit, with human and object interaction, designing and making process which is intertwined in the action of artisan's hand. Smart Code defines the question's new architectural space to feel the power of the blow and the resistance in the new design and construction process which emulates craftsman production. Smart Code is a system designed to store and circular the architect's design and architectural design information to change the position of an architect as a hacker, as a moderator, as a decoder, or as a technician. With Smart Code, the broken traditional relationship between designer, producer, and consumer is restructured between humanity and machines, and the role of the master builder is regained. Smart Code can be a new brick of digital era. Thank you so much for your listening.
Okay, we have some time for questions, because you were quick through the whole thing. Maybe too quick for the audience, no? Henry? Yeah. Sorry. No, I can do that.
Okay, hey, thanks a lot for your presentation. There are a lot of ideas in your presentation. As Wolfgang said, it went very fast. Oh. So I'm trying to catch up with all the things that you are trying to share with us. And the one thing that I'm puzzled is your term smart code, right? Yeah. Because code as a word suggests, you know, like a piece of fabric that you are dealing with the skin. You yourself say it's not the skin, it is more. So then I'm wondering, okay, but then what is it? Can you give a more concrete example what you think smart code is or should be or will be?
Yeah. Right now I'm working on it. In 2-3 months we will be documented all the smart code. We're gonna test smart code in digitally, in augmented reality and in the physical. So after that we're gonna conclude that smart code is this. But right now smart code is this much. I don't want to give a hint.
You suggest that smart code will work only in the digital reality?
No.
No.
Digital reality and also physical production with cobots. How we communicate the machine as a digital artisan.
Hi, hello. I would like to ask how do you plan to quantify your thesis and how do you plan to potentially introduce prefab or fabrication in the process of using the smart code?
Right now, how am I gonna tell? From 40 years, I'm gonna collect some information, some buildings, which I know the buildings, but I'm not going to tell, and collect the tectonics, digital tectonics and architectonics of those buildings and try to create a matrix. So after that matrix, we're going to prepare our tectonics, what can be. Then from those points, we're going to test all these modules by digitally and physically.
And if I can have a second question, do you plan to the output become some kind of like a product or something that could be used in the construction process or more in the design process?
Both of them. So that's all. The problem is I'm trying to regain the role of an architect again. I'm trying to push the architect to construction. That's why both of them.
Thank you.
Thanks.
Okay. Any further questions? You already want to order your smart code? Okay. So we have to wait a little bit for that. Thank you. Sorry.
Yes.
Yeah.
Thank you for the presentation. I just try to understand the issue, like the example that you showed us from Japan.
Yes.
And the connection with smart code, how it will be. Like, I mean, I just try to imagine, like, what kind of a thing as a smart code, what is it? Like, I mean, right now, as an idea, like.
Right now in my presentation, I'm not explaining what is smart code. I'm just explaining with the Japan example, carving can be a new type of construction because we all build on top of each other. We don't carve anything. But it's another way of constructing something. I'm just giving an example of there are tons of ways of constructing stuff. So smart code is going to test all these construction methods. And maybe in the end, I'm going to blame academics that they can't teach us very well, or I'm going to blame the consumers. I don't know, like I'm trying to filter the gaps between all sectors, like design cycle or investor cycle or manufacturer cycle, because tons of stakeholders are in design and construction process. So I'm trying to invest all these missing points, which I already did some of them, then produce new type of construction methods. Maybe at the end it's gonna fail, maybe it's not gonna fail, but I'm trying to make a smart code.
Okay, thank you.
So, any further questions? We still have 5 minutes. No? Then You're allowed to applaud.
Thank you.
So we have the next presentation coming from Scotland. I have to say, it's called, complicated. Huh?
Oh, my name.
Yes, your name?
Erfan.
Erfan is Zamani is doing it, and it's called
Discretization Design Strategies.
Discrete Design Methodological Classification. Yep. Okay.
Thank you very much. Thank you. Yeah, it's fine. The new version, yeah. How does it work? Okay. All right. Thanks for having me here. My name is Erfan. I'm a PhD student in Robert Gordon University, Scotland. We conduct this research with the help of my supervisor, Dr. Theodoros Dounas. Actually, my PhD topic is about discrete. Hello? Okay. It's about digital design methodologies, specifically focused in discretization and its integration with robotic. This piece of work is specifically working on a methodological approach to classify the discretization approaches and to analyze the case studies. The idea, if I wanted to start very general, the idea of this research came from this sentence, rethinking about the production chain in architecture, how we can optimize the architectural production chain. It might be a very general question, very broad question, but we were thinking about the DFMA, Design for Manufacturing and Assembly, how we can have construction with less emissions, how we can construct homes cheaper, how we can use automation or smart machineries to optimize the process. And also, we were thinking about the integration between the all stage of design, manufacturing, and assembly, actually manufacturing of the building elements. What is a discretization? There is a typical definition for discretized or discretization. We generally use discretization. Discretization means breaking down something into the smaller and buildable stuff. For example, we built our walls from brick, very traditionally. In architecture, we can say that it's more about geometry. We have complex geometry, complex relations, and we are breaking it down into the understandable geometric relations. It's a I would say traditional definition of the discretization, but there are some new definitions, like the ones that Gillian Restin working on it recently. It means that look at the architecture as the science of the science between the parts. It means that look at the building parts as general, flexible, reusable parts. Very simple question, very simple example. Imagine as a building that we have column and beams, and we can use one element for both. So in that case, we can get into the science of the parts to have more flexible, open-ended modules that we can reuse them, reassemble them. Methodology, I don't know why the quality is very, it should be a better quality, it should have a better quality, this image, anyway. Yeah, we started with the literature. What does the discretization mean? Is there any similar research? Is there any definition for that? How does it work? Is there any case study? Is that any architect that already used discretization to build something actually in practice? After those, we went through the experience. I mean, the prototyping, designing, recreating all those case studies that we had, and to stand on behalf of the architects, actually, the actual architect of the case study, and recreate them parametrically. So we had case study, for example, case study number 1. We divided into the process of the design strategy. What did the architect actually think about? What was the start point? What strategy the architect had to develop that start point? What was the stability strategy in the modularity aspect of sorry, I'm still a little bit sick. The stability strategy, the modularity aspect of the case study. What was the relations between the modules? How does a module stand among its neighbors? What is the positioning? What happens if we change the position? What happens if, imagine, in this wall we have, let's say, 100 bricks. What happens if we rotate one brick? What happens if we define the algorithm to rotate all of them? And assembly strategies. What was the strategy they had? Did they use the traditional method by hand, or did they use the robot something? So we had case studies. We decode the case studies parametrically using Grasshopper. We went through the modules, and we went through the geometric relations between the module. We tried to generate algorithm after each analysis. So we had a factory. We give the case study as an input, and the thing we expected to get, no, we got it 50%. 50% was failed. The outcome, the expected outcome, was parametric algorithm to create those case studies. Some of those case studies, they actually have built or designed by discretization methods. Some of them not. So we recreate them with this. Okay. Thank you very much. Actually, I need it. Thank you. So, we had three categories of the case studies. First of all, built structures, the structures that are actually built. We started with traditional brick wall, the normal brick wall that we already have. Some of these, for example, the number 8, the clay 3D printed houses that is in Italy. We were thinking about the integration with the smart machineries. Some of them, like number 4, for Kengukuma, we were thinking about the modularity aspect of them. Or some of them, we were thinking of the different types of fabrication, like the number 6 in the Stuttgart University. Some case studies have been built under the scale, I would say pilot. And also some of them, there are some kind of approaches that are in the papers. They are not making them anymore. It was something like 48 case studies. I mentioned some of them, but I'm gonna get in deep about 4 or 5 of them that what did we do actually. So about traditional brick wall and some similar examples with the traditional brick wall, we use the same logic for that. We use the final geometry as an outline, and then we divide it into the curves. So does it have any laser? No, it's okay. Just come here. We divide it into the curves, and we apply some plane on that, and then we morph the bricks onto the plane. The outcome of that, we got the final structure using the modules. The British Museum roof court was a good example because we used 2 types of discretization on that. It was one of the oldest examples of the discretization in practice. First of all, we have final geometry, again, same logic. We divide it into the 4 sides modules, and then again, we subdivide it into the 3 to have the accurate modules. And for this example, we had final outline again. In this case, it's not the final geometry, it's just the outline of the final shape. We apply the network of the curves on that, and then we extrude the curves and make some kind of modules that are not like normal bricks. This one, we had the final geometry. Actually, it's not a complicated geometry at the end. We applied the network of the points. We morphed the modules to them, and then we got the modules, final structure, including the modules. And this example, as you can see, it has more extended, actually, description because it was my master thesis. Mogarnas is one of the traditional architecture decoration in actually Middle East and in my country, Iran. So in this case, we had 2D shape of the module, like this. We said parametrically, we defined it like that. Okay, extrude it, repeat it, 360 degrees, come up, scale down, and repeat the same task again until you get the top row. All of those case studies that I went through had some kind of common ground, had some kind of similarities. It made me to make some kind of classification, considering its start point, similarities, developing plans they had, and all of this stuff. Many of them, they use computer growth. So in that case, they define the module first, either parametrically or either by hand, I would say. They define some kind of algorithm, and then they grow the modules. In that case, we can have some kind of shapes or geometries like that, that it looks like totally generative, but we can give it border. We can shape it by giving it border, and we can make some beautiful things. And after I played more with that, I got some kind of hybrid methodology for that, that we can have the outline, we can have the module design, both at the same time as a starting point, and we can make some funny shape like this rhino here. Don't try this. I lost my laptop to generate this. I burned the CPU actually. It's something like 1 million modules. But in that case, it can be a hybrid. So we can change the module shape, and we can see what's happened here. And we can change the final geometry outline, and we can see what's happening at the end. So it's like a circle process. The other category that some approaches like tessellations or this stuff, we can have the final geometry as a surface, and we can subdivide it into the smaller pieces like this one. So we can have any kind of curvy surface, or even sometimes volume. We can divide it, break it down into the modules, and got the structure with the modules at the end. Also, there are some kind of methodology, there are some kind of approaches that are working with the cross-section in terms of putting two kind of surface to each other and get the common line and make something like this. For example, this one is a tangent plane approach, but this one, we can have two surfaces, we can put them like this, we can rotate them and get some kind of volume on the top and on the bottom. If we apply this in a line, we can have a surface on the top, and if we apply it on the network, we can have a volume. So at the end, I got through the three categories: generative growth, I would say the computer growth, subdivision, and cross-section. Although all of them, they have some kind of limitations, they have some kind of potentials, but we kept all of this in this stage to think what we can do in the next stage by, integrate them into the robotic and fabrication methods. But until now, what is the functionality behind this? These are just some sketches that I did. I couldn't make any building in a real size by this approach, but I made some products with this. We aim to make a general, actually classification, general algorithm that we can use it in different scales. So until now, I could have made it in the scale of 20 centimeter. What about the next step? I would say, if we can use the knowledge and nature, the knowledge of the nature of the modules, and transfer it to the robots, we can have some kind of DFMA, not now, maybe next 10 years, that is specifically working for the discretization, modularity in design, to have more optimized, actually, construction process. Thank you very much. You need this? Oh, you have one.
So, again.
This water saved me, thank you.
So, questions to Aberdeen.
Okay. Hi, thank you for anyway, and I thought, is there an issue in your research, issue of optimization? Because I think that if something can serve two functions, then it means that it's not optimized for none of them. Like, let's say if something can be a brick or a column or a beam, it's not optimized. A brick is not optimized by default.
Yeah, brick is not optimized. The thing is that I meant from optimization in terms of emission and affordability and speed. We cannot suggest any particular element, any particular part like brick that it is optimized. No, it's all about digital integration that we can use different kinds of modules. It's not about the material behind that. It's about the actually process of the design from the scratch to the robot that robot is going to make.
Okay, so finally, the gain will be the time, the cost, the money, then the material.
Material is not the case in my research. For sure, material is the case. But it's about the circular actually process of the DFMA that we can have the design, give it directly from the software to the robot, and robot can maybe manufacture the module by 3D printing or anything, I don't know yet, and assemble it. So the fact is about removing the human operators through this process, removing the steps, removing some kind of bureaucracy, I would say, and make something that it's more automated. It's not complicated research. It's not a complete research, I would say. For sure, there are a lot of challenges there, and the most challenge I would say that is really expensive. It's a lot of new technologies we need to apply for that. But it's about moving through this. It's about doing the first actually base, doing the maybe key step to go through this. And my own actually, my eventual goal is that after end of my PhD, I can have an algorithm that I can give the design to that, and a robot there can make some scale model as small as this chair. Not very fancy. Thank you.
Okay. Any further question?
Hello, I would like to ask you, have you thought about recycling materials as well? Do you implement this for bricks? You mentioned about bricks.
Recycle material.
Yeah, do you recycle the bricks that you do the simulation?
It's
the
not,
optimizations that you...
It's not only about the bricks or any kind of materials. The thing is that if we can have some kind of modules, let's say make from the wood, not brick, any kind of material. I'm not focusing on the material at this point. We can build something with that. For example, we can build a pavilion with that. We can deassemble it. We can put them and use them again. So it's not about the actual chemistry of the material. It's about reusability of the material.
Okay, thank you. Thank you.
I would like to ask about the algorithm and where you see it going in terms of, it's funny that you mentioned that your laptop burned down during the process. As we all know, the process of calculation is quite labor intensive in terms of hardware. Do you see your algorithm, or do you see some kind of optimization in the way that it is calculated so we can possibly create such works on simpler devices?
It's actually I had the same problem because I got a project with the office in the UK, and I made a lot of perfect algorithm for them, but they couldn't open them because it was too heavy for their computers, and it was a big fail for that project. It is a problem, yes. It is one of those limitations that I even now I faced with that. I have a very good computer, but I couldn't apply all the algorithms. Like I burned something very expensive, cost me a lot. The thing is that I use Grasshopper. When we go through the Grasshopper algorithm, we can put some more time to optimize the algorithm itself. It's totally software. It's not going to be much easier that everyone can use it, for sure. Not in my knowledge now, maybe in the future. But we can do it somewhere that everyone can open it with a normal laptop and we can play it with normal laptop.
Any further question? I would also have one. So okay, thanks. You mentioned, in answering questions, you mentioned or quoted removing the human operator. So how do you see the role of the human in that?
Yeah. It's another challenge. When I was reading about what may happen if, for example, let's think if I would be the god of the architects and I can say, yeah, it is the process you should follow, but what would happen, what challenges would I have? One of that is that one, human operations, what's going to happen for that? There is economical aspect of that. I'm not going to go through this, it's not my knowledge. But human operation, specifically, I mean that that black box you said in your presentation, we can give some tasks to the computer, not as AI, but we can, for example, we don't need to produce some modules in the country A and send it to the country B to build it there. If we can, in my dream, we can have some kind of a small factory in each building construction site that we can build the modules there, assemble it there, and designers can control all this process. That is kind of.
Okay, kind of. We can talk about it later.
I would like to maybe extend Wolfgang's question. I would like to ask about the task for the architect in your approach. So the architect is a coder who's implementing one of these three strategies to discretize potential basic unit for building things. Yeah?
I would say I myself, when I'm designing something like this, it's not architecture, I would say it's something product design or something, but use the same knowledge. I see myself as a digital designer, as a designer who deals with the computer, who deals with the code, not a pure coder.
Yeah.
Because I would say dealing with some kind of generative systems needs some kind of actually design behind that we could deal and we can give a good code to get a good result. And also in some approaches that I mentioned, there is art behind that because designer actually design the final geometry and just get the parts from those geometry. So there are some kind of approaches like that. It's not just pure coder and pure programmer. I'd say.
Yep. All right. Thank you.
Okay. Maybe. If there are no further questions, we go on, and you can still ask at coffee break afterwards some questions, I guess. Right. Okay, so thank you.
Thank you.
We're going on to the last presentation from Prague this time. So again, it's a question of pronunciation.
Lucia Cyprianová, and should I pronounce also the name? Okay, so it's a simulation of human behavior as an auxiliary design tool.
Haven't much left to do, so.
It's something. Looks like it's missing something in there. Can you put it like? Oh, okay, yeah, it's this one. Right, I saw. Okay, so good afternoon, everyone. So my name is Lucia Cyprianová, and I come from Prague, from Czech Technical University. And my today's presentation is about simulation of human behavior in space as an auxiliary design tool. And basically it's kind of a review of simulation methods, software tools, and some future prospects. So here you can see the content of my presentation. And I start with short introduction. So human behavior is very complex, and it depends on numerous factors. And I think we can, as architects and urban planners, we can agree that this relationship between human behavior and the physical environment is very important, and is one of the starting points of the design and planning. And the thing is, it's kind of difficult to predict human behavior accurately. The designs of architectural or urban projects are mostly based on the knowledge, on previous experience of the architect. Then there is a process called post-occupancy evaluation that helps us understand how the place really works. However, thank you. However, this evaluation can be done only after the building is actually built. So it can help us to derive some generally valid behavior patterns. So we can learn from that. But for the new design that is every time really specific, we can really predict based on this the human behavior. However, with today's technologies and with the digital simulation possibilities, we might move from the post-occupancy evaluation to pre-occupancy evaluation. So if it is possible to predict human behavior accurately enough, and we have a tool for that, then it can be an auxiliary tool for architects. We could verify how people behave during the process when we are modeling our design, and maybe some problematic parts of the design can be revealed soon enough to change it, so it can save the costs and later when it's maybe not possible to change the design. So despite the fact there are already these simulation methods available, architects and urban planners are not using them in daily practices. And so to identify the reasons why is it like that, I started with a review of existing available methods and tools, and this should help me to move further in the broader research question that sounds how to make this digital simulation more available to common architectural practice. I was doing this research, what is available and what is relevant for the field of architecture. And this is basically the things that I'm going to go through now. So there are some methods available. There are some models that have been developed for mostly specific case studies, and there are some tools that are available, and there are some relationships among them. So to start with the models that actually exist in the field, we can talk about pedestrian or occupant models. So as far as we talk about public spaces, shopping malls, outdoor environments where we are interested in to investigate the flows of the people, to evaluate comfort, accessibility, or safety issues, it's pedestrian models. And then if we want to evaluate, for example, building energy efficiency and stuff like this, then we talk about occupant models. The most used digital dynamic simulation methods that we can find are the particle-based methods, where one of the most used for pedestrian models is a social force, where humans are understood as particles that subject to some physical and social forces of mutual attraction and repulsion. Then another case is potential field. Then fluid-based methods are used to model humans as flows. So it's more for those pedestrian microscopic models. Then there is another approach using cellular automata, where we can model a space as a grid of cells, and each cell has some assigned state, and according to some rules, the pedestrians are moving around it. However, the method that is bringing most promising results is definitely agent-based models. So agent-based model is basically a system assembled of individual agents, and each of them has a decision-making ability. So it can help us to simulate those dynamic processes that include interpersonal interactions, as well as interactions of individuals with the environment, or the some objects in the environment. So as I talked about, each agent has a decision-making ability. There are actually more ways how we can control this behavior of an agent. Mostly we talk about bottom-up strategy, that an agent is designing according to the current environment and some state of that. However, some approaches also try to combine it with kind of more top-down approach, so there is some higher control that is assigning some goals or tasks for the agent. Here I chose some of the, I think, most relevant for that might be used in architectural fields. And I would start with a rule-based approach, finite state machines, that has been used in game development a long time. And it's pretty simple model where some conditions are defined and states and some transitional rules. So if I try to make a simple example in some urban situation, we can define, for example, those kind of states or activities, and then we can define conditions, and every time some condition is met, the state is changed. So this approach, yeah, okay, so then I go to another approach, this called behavior trees. Trees is also rule-based, and you can see pretty complex example in here. We can again think about some example in, I don't know, a square or something. So it's basically a tree structure that is being executed from top to bottom, left to right, and if some conditions are met, then some activity it's executed, and it's like the end of the tree. However, if something is like false, then we go to another branch, and like this, according this current situation, the agent can make his decision. So this can be used, for example, in some like touristic spaces where people are more reacting to the environment itself, and they don't really have the given goals they want to do. And another way what we can use is a Markov chain. Here you can see an example of a case study developed by Kostas Heliotis, who used this model to simulate behavior of people in a park. So it's basically a stochastic model where there are given some probabilities of transiting from one behavior or state to another. Then maybe more complex approach that is also used in game industry is goal-oriented action planning, where it's like more this combining with the top-down strategy that an agent is assigned some goal he needs to fulfill, and then there are some available activities. So again, if we consider something like happening in the town, we can have these activities, and then we have the beginning state and the goal, and then like those activities are assembled, so the initial conditions and results are met, and then the like cheapest version, if there are like multiple chains of activities available, is chosen to achieve the goal. However, it is not being used in architectural or urban models because it's pretty complicated to implement. Then another approach that there are some studies in architectural design is the narrative-based modeling, where each agent has a narrative that he needs to follow. For example, here that was a study about a hospital, so there is pretty like straightforward that what a patient is doing, what a doctor is doing, how they move, and then so basically they are following this plan of activities. However, there can be some interruption, some interaction, that something happens and then it's like some unplanned narrative going on, and then it goes back to the plan one. So here again, if we think about some implementation in some square, for example, in the town, we can think about this kind of chain of activities, and then there can be some interruptions where agents do something else and then continue with that. So this is like pretty promising approach how we might we might simulate people's behavior. And then there are like, if we are talking more about AI strategies, so maybe one of them is reinforcement learning, where it's like a little bit more advanced than just the Markov chain. Mostly we use for this Markov decision process. So there are also probabilities, but however there are some rewards. So an agent is learning by receiving the rewards by choosing different options. So in the end, he should be able to choose like the most beneficiary chain of activities for him. And then we should also talk about artificial neural network. So that's a structure inspired by functioning of the human brain, and it has a capability to learn from data to make predictions or decisions. It comes with many benefits. So in the end, we can get more realistic simulations of decision making. It's pretty flexible. It can maybe capture more subtle variations from large amount of training data if you compare it to rules that we just needed to define. But it's there are some limits. So there are high requirements on computational resources, and it can be difficult to interpret the model's decision and debug it because it's kind of black box for us. Then I was like looking at the simulation tools that we might use. So for the pedestrian models, there are mostly tools for transportation systems. So they are not really great to like to simulate the reactions to the different changes in the space. It's more about the traffic. Then there are stuff that help us to simulate evacuation scenarios, but they are mostly working in a way just there are people, the evacuation starts, so they are moving the shortest ways to the exits, so it's also not very applicable. And then there are occupant models and tools for this, but here it's mostly concerned about these like physical things in the building, so how much light we need, how much energy, what should be the air change and stuff like this. And it's also not about this like more psychological aspects of agents. So then basically there is another way to use a game agent for that. For example, Unity, where it is pretty flexible and it comes with many assets and plugins that can be used. However, the expertise is required, and also some programming knowledge, and it's not that easy to develop more advanced model. Then if you just compare 2D and 3D, so most of those tools, they are just working more like kind of like 2D layout, and they on this make like 3D visual representation, but it's not really 3D. Only like Unity comes with the option to really use the navigation mesh as some kind of, for example, wavy terrain and not just the flat surfaces in different levels. And so if we work in 3D, it's of course there is high complexity, it's more difficult to develop the model, harder to validate, but in the end the results can be more realistic than in 2D. So this basically are the stuff that I was talking about today. And to come back to my question from the beginning, so what are the reasons that digital simulation of human behavior is not yet commonly used by architects or urban planners? So you can see that the development of such a simulation model is really complex process that requires expertise, a lot of data, software license, and the possibilities of the existing tools are limited. And maybe then we can also talk about the lack of awareness among architects, so not many of them are aware like something like this is possible and that it maybe can be beneficial. How to make digital simulation available to common architectural practice, or at least a little bit more available? So that's the question that I'm dealing with right now. I'm like kind of in process where I want to, for the beginning, develop a case study where I try to simulate the real situation. So basically just to make a replication of this situation. However, there is a problem with the data and like from what to learn the system and then how to validate it. We have some data from Mariánské Square in Prague, where it's data from video recordings. So we can analyze some patterns in there, but it's just one space at specific time period. So I'm not sure if it's really enough for this. So yeah, maybe like I will start with that, and during this process I would like to try to define the requirements that this tool that architects might use should fulfill. And I would like to then like do some experiment to test this some kind of demo version, how architects like see it in their practice and what they would expect, so that they might use such a tool in their practice. Yeah. But then it's like the big question of the complexity. If it's possible to create some tool that would be easy to use with a friendly user experience, and on the other hand, it would like comprehend all those complex aspects of the human behavior. So yeah, that was basically that. So thank you for your attention, and I'm happy to hear your questions.
So, how are your questions? Okay.
Thank you for your presentation. Maybe not in terms of questions, but maybe some kind of reflection that the reason that comes to my mind why architects are not using this kind of simulations is a legal environment, legal requirements. Because, for example, here in Poland, the evacuation reality is about the shortest path from point A to B. There is no point, no place for agent-based models. So this may be one additional reason why architects are not using that. Legally, they are not required to make it. So why to make something that you are not required to in terms of, you know, time is money?
Nobody pays.
Yes. Well, like these evacuation models, I think they are being used, but in really huge buildings, like if you are designing the football stadium or something like this. But it's not really what I'm aiming for, because what is more in my interest is to explore those psychological aspects of human behavior. So I would really like more see like tool where you can, during you are designing something, you can just let the agents go in there and you can observe how they behave, and if you change something in your design, so you can evaluate it in this process and to see the differences of different designs. In this way, how do people react to this, and if they use it in a way that you think they are going to use it, or if they behave differently, and if they behave differently, then you can maybe think about why and change your design. But it's far from this today's simulation models. I think it's right now impossible. So I need to find just little step where I can move that, because I'm I know that I can't do the so complex simulation model alone, or in a small team of people.
Okay. Adam already has a question. Then
not a question,
and
but a comment. Have you heard about Ben van Berkel using simulation of the movement of the crowds as one of the most important factors during the design of one of railway stations? He was designing something about 15 or 20 years ago. There's a book, Design Models, by Ben van Berkel and his partner, and this case is mentioned. So maybe it could be a good reference also to use.
Okay, thank you for the reference. I admit that I haven't really read this.
You
book.
have a lot of them, so but yeah, here's one more. Yeah.
I have a question in regards to the different models of simulation. In your opinion, which one do you think is the most easy to use and at the same time most human-oriented in terms of the realities of how humans use, an exception of artificial neural networks, which strive to be them? What do you think is the best consensus between those two types of simulation methods?
Well, it definitely depends on the specific use case. That if we think about, as I mentioned, the hospital case where the roles are kind of strictly given, who is expected to do what. So it's maybe different from some kind of urban situation where it's maybe more random what people do. So that's one thing, and another is also maybe your capabilities as a developer of such a model, because most of them really requires more advanced programming knowledge to develop them. So if you think about this, maybe the easiest way to start with are behavior trees, because for those you have some tools where you can, as I showed the schemas, so you can basically just assemble them out of the visual components. So it's easier also for non-programmer to develop such a model. But it depends. If there was a huge team of developers working on it, then maybe the more realistic results would be achieved by those more advanced reinforcement learning and this kind of stuff.
Okay, thank you.
Okay, I give it afterwards to you. First, I would like to comment on the first question there, where you mentioned that, okay, you don't get paid to do it, so you just follow the rules for doing it. That's very logical and will happen. But I think your simulation could be very worthy for trying out how it really works to establish the rules. Because with the simulation, you can test, okay, what happens if someone is dropping and things like that. What does that affect the evacuation plan when there is a panic and stuff like that? So that could be interested in terms of human behavior in doing things like that, I think. But I had also another question. You know, one of the common post-occupancy design versions is when you design, let's say, a park and pathways through a park. In former times, the architects or landscape designers designed that, and they picked special viewpoints, how to design that. But sometimes that changed into only defining the most important pathways and then leave the rest to what happens after people start to use the park. Because then naturally it ends up that new walkways are created because people just walk in certain directions that the architect or landscape designer hadn't had in his mind. So how is this with, you showed this example of the Markov chain for this park thing. What do you think? Is it worth doing it in simulation, a thing like that? Or would it, because it only makes sense when you also have the 3D there, because 3D, as we all know, has a big influence on your walkways and decisions where to walk.
Yes. So so 3D is definitely important if we talk about the landscape. Maybe if we talk about the building interiors, it's not that important. So we definitely need 3D for this. But this question about like where people walk, I think it's like, in most cases, maybe it's the kind of the shortest way algorithm. So, you know, the agents, they have the like where they are and where they need to go. So they are just looking for the shortest path in a place where it's possible. So if there's tree or lake, of course they go around, but if it's grass, they just walk directly. And so basically you can combine this stuff in a model. For example, in Unity, you can use like nav mesh asset for this to finding the shortest path. However, then it does not include this decision-making ability, so then you can combine it with these other like processes that then he can decide, okay, I'm just not walking for the shortest distance, but I want to do something else because there is something in the environment or I have some higher task I need to follow. But yeah, basically this like creating routes according the shortest path, that's I think pretty like easy way how we can make the simulation if we have these points defined in the space.
Yeah. But that normally is not the best solution because, as you mentioned, there are other aspects to that. Okay, thank you.
Thank you for your presentation. It was very interesting. I have a question about disabilities. Agents with disabilities, how their decision vary in terms of between group people with different impairments and with people normal. In urban planning, it's do you plan to take account of these parametrics of accessibilities and how it influences decision in urban environment for people with, for example, using wheelchair? Yes.
Yes. Well, I think nowadays we like every time we design something, we must think about accessibility, and like considering agent systems, it's basically like each agent can be assigned some attributes, some like characteristics. So I think this should be included in the model that some number of agents should be, for example, be not allowed to walk somewhere where it's not accessible, and it should be definitely something that you should see in the model, that you have some red points there. Okay, I can't go here, so there you must think about that solution. So I think like it shouldn't be that hard to implement it in the system because the rules I think are, at least here, they are let's say, pretty simple comparing to other, all of the various complex behavioral patterns that appear that we might implement this.
Adam?
Thank you. Yeah, I was curious if you can already tell for which scenarios or maybe design task this might be most useful, if it's more for urban space or large-scale buildings, or you think it's maybe also usable for small-scale buildings, I don't know, some, I don't know, residential unit or family house, because it seems that you're simulating human behavior, which you can't really predict precisely very well, so you probably need quite a large amount of these agents to eliminate this, I don't know, imprecision. Or can you somehow collaborate on that?
Well, I mean, personally, I can see like the bigger benefit in like higher, like bigger scale, either the objects or the outdoor spaces. Because if I consider like family house, I don't know if it can be so useful for architects to see that, okay, there is someone walking from the kitchen to the toilet, and I'm not sure about this, if there is some benefit. Yes, you can like measure some distances or something like where he is walking. However, I don't think it's necessary that much, and I think it's the higher benefit is in like really complex spaces where you can't predict it so accurately just by your knowledge, because in small objects you can just guess, and probably you are right that it's going to work like this. So I would go for the larger stuff.
Yeah, thank you for the presentation. Maybe it is wrong question, but I just want to understand. Like when we talk about human behavior, like as also he mentioned, like this is just physical behaviors, or like, I mean, the interaction between the space, it's just on the physical level, like agent will open or close something, blah, blah, like the stative, like, you know, not feeling the space, like is it related? Like how is the limited version of this, your approach, you know? Like, I mean, it's like architectural level really, or like urban design level? I mean, if you are talking about the park, it has a lot of inside of it. So I mean, do you understand what I mean? Like, what is the limit actually in here according to your approach? Like,
I'm not sure I got it exactly.
Like, I mean, it is the limit like for the architect or for the urban designer, or I mean, also user also important. Like, is it physical behavior or like also sensorial behavior also included? Like, I mean, what is the human behavior? I mean, in your case.
Well, my case is not yet defined so specifically, but in the case studies I showed there, basically you have this, like, let's say 3 basic levels where it's either interaction with the agent and the environment, or it's like this more social, so it's interaction among agents, and then it can be combined, because sometimes like you come somewhere because there are other people, there is some activity happening, but it's also happening on a specific place, some location, so there is, I don't know, volleyball, playground, something, so people go there, so it's like connected. And then there is also another level that can be added, which is like this kind of like satisfaction level of agents, so that's another like way that can be included, that you have some other like set of rules or something that is telling you, okay, now he's unhappy because there is something wrong, and this one is happy because there is everything like all right. So I think like the options are basically unlimited, but everything can be included, but it's the problem of the implementation itself that it becomes really complicated. So I'm not really sure where I can get in the end.
Okay, thank you.
Okay. Thank you. Any more comments or questions? Yeah, one more.
Thank you for your presentation. I'm interested in what it was made. this based on a group of people and research about that people, or this is theoretic researching?
Well, so far it was more theoretic that I was trying to get this state-of-the-art research that is currently going on and the tools that are available. But now I really want to move it to more practical levels, so I would like to develop some model myself and to verify some aspects, but I need to define them more exactly what is in my power and abilities to do, because it's like, yeah, it can get really, really complex.
Thank you.
Okay, so I think we're finished then. Thank you for your presentation. And Adam will announce now that we can have coffee, or?
Yes, of course. Yeah. Yep. I'll check the timing. Okay, so we meet here at 4. All right? Yep. Thank you very much.
So we had a good time.
Yeah.
4 minutes.
Halo, halo. Teraz to... Zapraszam wszystkich... All right. Especially. Okay. Karolina, Milena. No właśnie. So, now we have the last session of today. This session will be shorter because the presenter of last presentation that was planned for today, Gökçen didn't manage to arrive. So we will finish earlier. Now we will have a presentation of Tuche and your surname? Gökçen. Yeah. Memory and space in past, now and then, collective memory in digital age. So the scene is yours, 20 minutes. Yep. There's a mic there. Yep. Good.
Presentation? Okay, yes, it's mine. Thank you.
Wie pan co? Reflektory są trochę za mocne.
Okay, hello. Thank you for having us here. So I'm Tuğçe Gökçen, and I'm coming from Turkey, Istanbul, Bahçeşehir University. And I think unlike the other of you, I'm not an architect. I'm an interior architect, and I'm also a PhD student. And again, unlike these presentations that we have seen so far, mine is a bit more on the conceptual level. So I hope that you can relate with it and it won't seem like off topic. So the title was Memory and Space in Past, Now and Then, Collective Memory in Digital Age. The questioning is started with the in-depth query of the phenomenon of the space in digitalization, which shifts the conventional spatial cognition. And by that, correlation between space experiencing mind and the memory are mediated by being mediated by modalities of digital mantras. And as an outcome, we can say that the memory is no longer restricted with what mind can archive or recall. And concluding with that, and the idea is to unfold the phenomena of the memory and space and its interrelations of formation of space and spatial paradigms. And by doing so, it utilizes the perception processes of space and spatial experience with collective memory, which elaborates cognition of space in conventional and digitized sense. So what overall the study aims to present possible future projections of these notions towards digitalization, and the notion of collective memory in the context of this digitalization is discussed over a data sculpture artwork installation of a Turkey-based artist who called Refik Anadol. Maybe you have heard of it. And the artwork's name is Melting Memories. It's eventually actually artwork, and it's a data sculpture, but we will see how it relates with the topic itself. And these are the sections of my study. So as an overall idea, we can see the main focused parts of each section. So the first section is formation of space, and as an outcome, it's a product of mind. And the second part is related with decoding the space, and in terms of spatial perception. And the third part will be related with the interrelations of memory, collective memory, and the space. And this part will be focusing on the memory processes. And the fourth part is actually kind of the case study part, and it is focused on the collective memory in digital age. This is the part where the digital turn in memory is discussed over. And as the first part, as the formation of space part, the main focal point is the space. And I try to be more compact about the presentation, so I have pulled out some main conceptions about the space. And so as an outcome for this section, the space as a product of mind, again, it's a mental process, or we can say that space as an enclosure where the actions takes place, and it is a level of perception, emotion, and consciousness, and it is a content, and it is a totality of objects, and space as interrelations and interplays, and space as codes within mind, and a set of relationships between objects and products. And I'm sure that all of you are, familiar with those terms and conceptions, but I will try to have a narrative out of it. And it is possible to say that the space as a singular concept is a phenomenon that we cannot reconcile with reality, but when it is perceived as an enclosure that allows activity and shelters individuals' parts within, space can be formulated as spatial being. So at the second part, decoding the space part, space is, investigated in terms of deciphering a coded message to a recognizable form, and then the perceptual conception and vision as the sources of the knowledge. And space in terms of activity of the participation as the user, and unity of space with individual, space in terms of readability, visibility, and intangibility, and space in terms of spatial perception and product of sensations, and a sensible sense, space, and immersive experience, and a building that is seen as a total object within the space through mind, and the building experience through people's actions as events. And overall, the space is an effective experience, and from values of domain and world of ideas to world of facts and reality. And I would like to read some of the parts of the text. Bergson argues that the perception develops under cultural psychological influences, and that the personal imagination world is formed around these factors. So rather than directly connotating inferences, images are perceived as singular and by their own, in which the viewer affected by the internal structure of their representations. So we are actually by alone and with it, our imagery and the space are affecting each other. So the image enables the individual to feel belonging to space, and the emotional bond that the human establishes with the space is the result of image and notion that is the process one more, which differentiates the formative space with the perceptual space. So this is the base points of the idea of how we engage with the space. So at the third section, interrelations of memory, collective memory, and space are discussed. In here, we are seeing the unity of spatial perception with memory, and the spatial experience creates the spirit of belonging, we might say. And the social space phenomenon, along with the social space, constitutes the memory. And perceptual aspects employs on the cognitive operations of memory within the city, and the image and space we have to mention, obviously. And we can mention about the dynamism of the memory, and in here there's a cut, actually hypothetical cut, the retrospective illusion, Halbwach says. So I will come to that later on, but let's keep it in mind. And the new image and perception are overshadowed by the past experience. recreating the former memories within a new context recursively. What we do, how we engage with the city is actually, these last three ones are the, main ones which are, structuring the study. And the regeneration of the past within the limits of today. And space as a living concept in the context of social environment and sensed information interviews with the user's existing experience. And the mind chooses what to experience. And we are actually within the illusion of the perception somehow. Maybe they're a bit floating right now, but I will relate with them again. And here, again, according to Halfbach's, the collective memory nourishes from the people's compatible body, and each people belongs within a group of society, accumulates the phenomenon through the cognitive process of remembering. Again, the principles assigns their connections and reconciles their memories that belongs to past. And a different and a new experience that is remembered as the resulting memory is actually the past experience, therefore is not possible to talk about the stability and the permanence of the memory. So far, what we have seen are actually the conceptual background about those main ideas in traditional sense that we can relate. And, how these three sections come together is that we start with memory and the main functions of the memory. It's a bit bright, sorry. So we start with the main functions of the memory, such as coding, storing, and recalling. And with the imagery of the space, and with the help of the indicators from the space, we get the spatial image, right? And then by the help of the stimulants and the sense through the senses and perception and experiences, and out of three, with the interpretation of each individual and their former experiences and their ability to interpret those, we end up with the we actually end up with this cycle, which is also by the help of the individual. If we enlarge the scale, the city, and the out of the city, there's a social production, which is pointing out the collective memory itself again. So there are some subcategories that we need to keep in mind when we are trying to understand this process. And here again, I am going back to the part that I mentioned about the illusion of the experience and the retrospective illusion that we hold tightly, even though with the memories we may choose to forget, seems more vivid and intriguing than the present, precisely from the younger periods of our lifetime. Thus, the new image and perception are overshadowed by past experiences. So I'm repeating the same thing once more to put an emphasis. And all kinds of perception involve memories entirely and through the perception process, and sensed information interviews with the user's existing experience in a way that suppresses the sensed information, which was the initial perception. What residues at the point is simply an indicator for the user to remember or recall. And it is actually what we, how we collect our memory and how we collect the experiences are actually, the articulation of the former ones. So we are putting over on top of it. It's not, slightly new, but it is at the same time. So there's an ambiguity in there. And overall, we can say that space and memory are suitable for both transformation and manipulation, because there's not a clear border, we can say, and they are too many factors that are within this process, production process, and the concept of participatory social memory may be utilized to transform the users within the city intentionally. yes, the resolution is bad in my sense as well. This part is the part that I'm evaluating the case study again, but let's start with a more generic sense. So the title is called, this section called Collective Memory in Digital Age, and I would like to start with a quotation from Michel Foucault. The way the past is represented determines what and how to remember it. And from seeing it in a more, again, generic sense and starting with the idea of the digital age, since I'm mentioning about the collective memory, I think it will be, suitable. I thought that it will be suitable to discuss what happened to public space in digital age. So we can mention about the multi-usage of introverted space as the public space, and we can say that the interior space as public space out of the lack of open or exterior spaces. So this is what we are dealing with nowadays. And we know that it's dynamic, we know that it is active, and it brought out the ideas and new forms of thinking, and we can say that it is timeless and limitless. So, out of knowing these, we can say that memory is a consistent phenomenon in which employs on relate ourselves within the present, enchanted and an effective notion, whereas history is a mere image of the past that entails criticism and analysis. And here, the recollection of notion of the mental process is examined through the public artwork. Again, it's a public artwork installation of Refik Anadol, that is the artist, and the name was Melting Memories. So these are, I'm sorry about the resolution, there's not much to do right now. These are different subtopics of the artwork. So the first one is the process of recalling, and the middle one is named as being there, and the third one is synthetic memory. So here, this is more proper. You're seeing some snapshots of the, animation of that artwork. The artist itself named those parts because of the data gathering process. So what we are seeing is that he intends to represent mental data of the memories on a plain canvas in an intelligible manner. So the artwork actually decodes the mapped neurological information to be experienced as visual and auditory language. And so let me go in. This is, again, this belongs to the data gathering process. In here, I have a few more related information. And again, this is how the interface is working. So through with the presented work represents a visualized mapped data initially belongs to human memory, hence to EEG waves. What does it do is actually through the EEG channels manipulated to represent visual experience also involves different aspects of memory such as long-term and short-term. It actually represents an exact visual model of the human brain memory process, and what he does is actually he, in an environment such as laboratory, they are trying to archive human beings' long-term and short-term memories in order to manipulate and somehow put it in a plain canvas. When I say plain, it's within quotation, of course. So it's not a plain canvas, but they are trying to find a way to capture those moments. And so in here, since since the accumulation of the collective memory, we can say that since accumulation of the collective memory rely on the faculties of individuals, it's also applicable to massive recollections of the memory. So, as a conclusion, overall, what we have seen so far, as the first part for the formation of space, we said that space is a mental process. And again, for the second part, space in terms of spatial perception and sensation. And the third part as the interrelations of memory, collective memory and space, recursive process of the image and space within the limits of memory. And as the fourth part, we have seen an artwork, installation. And three things are actually coming out as the most, important things, in my opinion. So we can say that rebuild of perception and memory through digital, and we can say that different time and space perception out of these, things, and there is a surreal illusionary experience. And the memory process of remembering and recollection have become substantial basis for interchanging and providing a tangible space for images and their conveyed messages, meanings, whereas recall does not indicate memory in psychological sense, but resides in the capability in the recollection of former experiences in order to relate them within a new facultative context. And this artwork precisely is important, not perhaps directly, but it shows that the admiration and the longing for past experiences neither have to be confined to the past, nor to the future has to be dominated by the past. So there's a chance to store the most precious memories or moments of our lifetime, even with a different dialectic. So it has the that potential. If we can do so, we can say that we can let them go more easily, so that the future will not be tied or formalized only within the limits of memory. You might think about that, what does it have to do with architecture or the space, and how we can. Okay.
Just 1 minute, okay?
Okay. So just with a sentence. So the idea is that since architecture mostly is something focusing on the permanency, and with the digital sense and with space and the relation with the memory, we can say that spatiotemporality is becomes more and more important in that aspect. So thank you. That's all from me.
Thank you for an interesting presentation. And of course, there is a time for questions.
Yeah. Yes. Hi. I would also like to ask you about the way that the data should represent the memory. So you mentioned that the neural network or the neural map of the mind has been gathered through the EEG waves. Yeah. Do they create some kind of like a height map? Do they create like a three-dimensional space, or do they create a two-dimensional animation or some kind of like?
It is, out of the data, they have created a 3D animation, but in a way, that's why maybe I can go back a bit. So these ones, you cannot see it very well, but the synthetic memory part is, created out of the AI, so it mimics the, what it sees and recall, and being there is the process that is directly seen, but it is represented in a manipulated way. It is 3D animation actually.
Okay, but like, can you tell us, for instance, are there like any patterns? Say, if there's a big wave, like a high wave, does it
yes
represent some kind of?
Of course, of course. So they actually, I don't have that images, but you know, they actually, of course, they cannot take all of the data out of it. So they have selected some channels so that they can manipulate it. So it is not the, you know, overall process, but you know, of course, there's an artistic side of it. But that's why I specifically say that, you know, the conceptual level is actually that I'm trying to base my study. So they selected some channels and they selected how it's going to represent itself. So that's it.
Okay, thank you.
Okay.
Thank you.
Thank you. I have to admit I was lost somewhere in between your presentation, especially at the end, because I was wondering of what type of space you are referring to. Is it a kind of architectural space? Or not, and why is in your fourth part, which is the collective memory in digital age, there is no mention of space anymore. And this example of this 3D animation going on in space, so what is the significance of the space then there? So, and how does that differ? Because you say, okay, past, now and then, so maybe you can explain that.
Of course. What I want to point out is that the fact that the temporality of the space, because you know everything is changing, and and if we would like to create something out, something new, and if we don't want it to be affected from any other thing, so we can do that if only we can have a way to do so. This is, in an abstract and conceptual level, and it's a bit perhaps out of scale example, but, space-wise, what it represents is that perhaps, permanence of those spaces, if we don't need to store all of the experiences out of the space, within our, abilities of mind, then we don't have to have that stricted spaces anymore. Maybe the temporality of the space is more important in, this digital sense. So what can be done in that area can be a question mark in that sense. I'm not saying that we shouldn't be constructing concrete buildings or something, but we can extend beyond the limits of our memory. Thus, the experiences within the space is not that strict anymore. So you don't have to rely on your memory that much. If only we can find a way to store them and re-experience them in a way so that we can decode them and we don't need the same places to have the same experiences. I'm not sure if it's the, answer. It's more virtual space then. Kinda, yeah. Okay.
Yeah. Any other questions?
Thank you very much for your presentation. I think you have a very interesting overview of all kinds of literature on memory and stuff like that, especially from a phenomenological background. And I was wondering, how do you perceive this collective memory? Because you didn't really talk too much about it. And especially with the relationship to the digital age. You talk about imagery and things like that. So what is your research agenda? Where do you want to end? One concrete example, I think we are currently building a collective memory through Instagram. Everyone who is on Instagram and puts almost real-time pictures on Instagram, what they are seeing, what they are doing. So in that sense, with all these people doing that at the same time, we are building, I would say, a collective memory. So how would that, do you agree? Do you see it different? Would you like to analyze it in a different way? Do you have different questions that you want to ask?
I think there are two parts that we need to, two big important parts that should be examined for the collective memory part. So one is the one that I briefly mention about the exact physical space and how we experiencing it in different scales, urban scale, smaller scale, interior scale, but in the sense of the big data and how we have the piles of information and how we end up with the collective memory is, I think it's another thing that has to be dealt by itself. Of course, I'm not denying it, but what I'm trying to focus on is that the traditional sense of having the experiences out of this space, and I think they should be two different things, and overall they can be affecting each other, but not in this study per se.
Okay, thank you very much.
Thank you too.
Thank you. And now Christina is welcomed here, so take your stage, yes.
Should be on? Yeah. Hello. Yeah. Hello, everyone. My name is Slotina, and I did this article together with my professor from Norwegian University of Technical Science and Technology, and it's called Exploring Architects' Perspective on the Digital World Using PPT Framework, or People, Process and Technology Framework. So I'm going to try to wake you up a bit, maybe, but let's see. Okay, about me. I am a PhD candidate at Norwegian University of Science and Technology in Norway, and I have a diverse background. I've studied techno-anthropology for my master's in Aalborg, Denmark, and I studied Bachelor in Architectural Technology and Construction Management from Denmark as well. And I've been working for the last 10 years in architectural practice, both as a BIM director, acting BIM director, and techno-anthropologist and constructing architect. I'm still practicing that, and in addition to that, I'm doing my PhD. So today, I'm looking from my PhD perspective, but I also want to thank my company Nordic for supporting this. Thank you. So my professors for my PhD are E.Hjelseth, professor from Norwegian University of Technical Science and Technology, sorry, and Michael Hensel from Vienna University of Technology. Yes, techno-anthropology. This is a most asked question to me. What is techno-anthropology? Because very often anthropology is associated with excavations and so on. In this case, this is social anthropology, looking at a technical field in very simplistic terms. So what techno-anthropology is doing is investigating and identifying the transformational and hybrid spaces that are being formed by looking at expert cultures and the nature of technology and how those are shaped in between each other. So techno-anthropology is like kind of looking at this small space in between the expert cultures and nature of technology. So my study is more from a holistic approach. So I'm not looking at a product, I'm looking at more the processes and how we collaborate and how we work together. Yes. So I also want to touch upon my PhD subject because this paper is part of my PhD. So I'm looking at interdisciplinary interactions in architectural projects through digitalization. And more specifically, I'm looking at virtual design and construction and investigating that through my techno-anthropological methods. So for those who haven't heard virtual design and construction is a digital framework that is trying to investigate digital tools like BIM and systemize collaboration processes. So it doesn't not only include building information modeling, which you might be familiar with, it also includes project, product, production management, integrated and concurrent engineering, project objectives, and client objectives. So it tries to have a more holistic approach to how we work together in architectural, engineering, and construction industry. This VDC framework is becoming very popular in Scandinavian countries at the moment. And there's been several attempts also with the European Union to have similar digital frameworks. So what I'm looking at is a transdisciplinary study that aims to explore how this VDC framework impacts the outputs and processes on how we work interdisciplinary within expert collaboration and conceptualize in the architectural, engineering, and construction industry. So my PhD topic is also looking into how does VDC impact the teams, and is this in some way also changing architects' role within these interdisciplinary teams. Cool. Yes. So for this conference paper, I worked together with E.Hjelseth, and we looked at exploring architects' perspective on the digital world using people, process, and technology framework. So what we wanted to look at was are architects aware of the changes in the AEC industry now in the Scandinavian world, and how these VDC frameworks are affecting the way we work? And also, are these virtual design and construction framework facilitating the needs of architects in these digital frameworks? So the methods I used was extended literature review after my paper in ECAD-E 2021. And then I looked at field observations of the VDC course at NTNU. And also I used semi-structured interviews and analyzed those interviews. Why I chose semi-structured interviews is because of my anthropological background. I feel like semi-structured interviews gives more space for conversation-style interviews instead of questionnaires or very strict questions that we need to follow throughout the interviews. Okay, so when I looked at the further literature, I also noticed that Schoen in 1983 already said that architectural profession has diversified and shifted over the years. So I feel like that is still present concept, and it's still shifting and it's still changing over the years. And the question is just how it's shifting, and are we part of this shift and change? So I also looked at, sorry, I don't have the quote here, but it's from Tangard, 2013. Mentions that new social material aspects of profession has been also revealed. So she says that not only like material aspects of like the building itself, but also paper and computer is part of new socio-material aspects of architecture and creativity in architecture. So I also think that maybe digital technologies like BIM visualizations, AR, VR, machine learning, production, prefabrication is also part of these socio-material aspects of architecture. So throughout my literature, I also saw that many architects are actually quite engaged with these new technologies and interested to to kind of take on and like try. They're very curious and seeing how can I play with this? How can I work with this? How does this contribute to architecture? What I write about in my EKD paper is that the access and engagement in the technology and BIM does not necessarily lead to a better collaboration interdisciplinary, because there's also other processes and also collaboration needed to be able to work with that. And that's something that I used in to also look into this paper was people, process, and technology, which also includes not only technology, but also processes and the people within the framework. Yes, throughout the field observations, I realized that there was very low representation over the courses at VDC framework courses. It was only like 3% of architects participating out of 200 every year for 3 years. But architects are part of the project development, of course. So that was interesting to see. And so my question was so what is the role of architects within this VDC framework that's being implemented in all new architectural projects in Norway? So, and also I wanted to look at is architects' role changing within these interdisciplinary teams? So I did interviews. I did 7 interviews with architects from 10 to 25 years of experience. I asked the architects that are already familiar with VDC framework first, because I wanted to move forward to the with research, so I don't have to explain them what is VDC in the interviews. So it was a conversation-style interviews, and what was interesting that came out of them was that. So I mapped it with PPT, and as you can see, the technology, even though I had specifically made questions very equally for people, process, and technology, technology was still mainly the subject of discussion during the interviews. So technology is definitely the most interesting part for those architects to discuss at the moment. But then I thought this is quite simplistic for me, so I wanted to map it a bit deeper, and I looked into Owen's Innovation Imperatives Roadmap. If you're familiar with that, it's kind of like a stack of roadmap. What I did was I moved it in a circular manner in order to see percent-wise what was the most interesting subjects covered in the interviews. So what was interesting to see was that, for example, economical aspects are up there. It's very low interest within these architects' discussions. Also, that the opportunity for reduced litigation is over there somewhere. It's also a very small interest at the moment. I don't know if that might change during the time, but yeah. So what was the most covered was opportunities, and that's actually not surprising because I interviewed architects that are interested in new ways of working, right? So those are that was also the subject that they were mostly interested in discussing, and it was equally opportunities between project and program. So, for example, one of the participants with 25 years experience was like, yes, I'm very into digitalization. I think my first meet with digitalization was, wow, blow your mind. So that was like interesting to see how engaged architects are with these technologies as well. So also quite a large percentage was enablers. And that's also part of people, process, and technology, sort of, here. And but even though technology seems to be pushing further the AEC industry, like quoted in Gade et al. In 2019 and Hermod in 2009 and Owen in 2013. It appears that architects participating in this particular research were interested more in the matter of how we can develop architectural profession. So people were more like the integrated people was more discussed than the technology itself when you look in a more detailed manner. So, for example, Danielle, these are pseudonyms, but so they're not real names. She said that in the projects that I'm used to work in, the big complex projects, architects are often leaders. So I don't see that changing, but it's interesting to see that there are almost no architects in this VDC course, and it is mostly entrepreneurs, and they're high-fiving on stage, and they're like, this is their thing, you know. So she said, I just think we should be a bit aware of that to be able to position ourselves in this. If this is something that the whole building sector is trying to work towards, and we are supposed to lead those projects also in the future, then we need to kind of own this framework. So I think that was also one of the conclusions in my work, was that the architects that I interviewed are familiar with the facts that a VDC framework can bring to the AEC industry, but they also mean that more architects should be familiar with these processes and changes in the AEC industry and be part of the shifting of the disciplines and roles within the AEC sector. What was also interesting, I don't know how much time I have, a few minutes? I'll try to wrap up. Okay. Yeah. Yeah. Well, I'll try to wrap up because I also wanted discussions. So the two kind of main strands came out of these interviews as well. So some architects thought that it would be more interesting if architects would take on like a master builder role, where they would be able to make decisions and have overview of the whole AEC industry. And all the other disciplines. So take a project lead role, for example, but be able to also know and work both from like sketching of the design up until the delivery of the building to the client in the building project. And then there was also architects that were more interested in fully integrated kind of architect role that I called. And they wanted, or they were saying how specialized architect role becomes with this time, because when we look at architects now in the architectural office, it's not only I am an architect, I'm also an architect specializing in healthcare projects or airports. I'm specializing in building information modeling or programming or visualizations. So what they meant, this strand meant that it was more important to collaborate with all the disciplines early on in the projects to be able to deliver a successful project at the end of the project. Good. So further work. What I want to look at further is either to look at architects not yet familiar with the VDC framework and see their perspective on the digitalization. Or otherwise, the idea of the PhD was also to look into other disciplines and interview those and then see how that integrates within the architect role. Yeah, and I also wanted to maybe look at different roles, and that's like this part of here is more like a discussion part for you guys to also like say, what is this interesting, or maybe this is interesting. And then what are the new socio-material aspects of architecture and how that is changing our way of working, and maybe our digitalization is also changing the way we transfer knowledge between both interdisciplinary and also within our discipline. Cool, thank you so much.
Thank you.
Sorry, it was a bit of a run.
So, as usual, questions, please.
This one in the back. Cool.
I'm one of the architects which is not familiar with this VDC framework. I'm not sure if I'm the only one. Could you just briefly explain it, please?
Yeah, so VDC framework is trying to use technologies available, like building information modeling, for example, and integrate also processes and objectives, like project objectives and client objectives, and have that as a holistic way. So it's a way of working. This framework is trying to provide everyone in the building industry a way of working together. So it's not only for architects, it's basically for interdisciplinary teams, how we're working together. So there's certain methods that people that go through these courses or people that work in the projects that uses VDC are like bound to use in a way. So it's very structured, I'd say. Yeah. I think there was one more question in the back as well, yeah.
We can go to a different question.
That's okay, yeah. But I think that's very true. And the question is, how is the pie split as well? Because are we also taking on new roles within architecture? That's also an interesting subject, I think, to think about. Because maybe some years ago there was like more graphic designers working with the visualizations, but now more and more architects do that as well, you know? So that's interesting.
Okay, hi, thanks for your presentation. I wanted to ask if in VDC there is a place for some midterm reviews, self-assessment, that if we are all pushing forward, is there a place to check if we are pushing towards the right direction, and if the client participate in such a reflection, if he can confirm that, okay, this is the right direction, so we can be sure as a design team that we will be back behind this moment. Is there a place for this?
Thank you so much for the question, because I could talk about this for a while, I think. There is a lot of evaluation throughout the VDC. So there's part of VDC is also metrics. So it tries to measure the project throughout the project phases. And it has meetings where everything is being assessed. What is difficult from our point of view as architects, I feel, is that architectural qualities are not easy to measure. And that was one of the points brought up in the interviews as well. So it's easy to measure the time. Are we doing this? Are we everyone present in the meetings, for example? That's one of the measurements. Are we on time on a building site? Have we decided what is the return for answering the questions? For example, if an engineer sends you a question, how quickly you answer. So that's being measured, right? But what is missing, I feel, is that architectural quality measurement, which was brought up in the interviews as well. And if architects are not part of developing this framework, are we missing that out? And what are the project's end results? as well.
And is the client there during the meetings?
Yes, the client is there. Entrepreneurs, clients, everyone. So part of the ICE meetings, or integrated concurrent engineering, is having all the disciplines and all the participants present in these meetings.
I remember there were more questions. Gigi, please wait.
Hi again, thank you for your presentation. I have a question in regards to the role of small architects in the VDC program. How do you see solving the problem of engaging smaller design studios which might not have the manpower and the capabilities to be fully involved in the VDC framework?
Yeah, that's also a good question because VDC doesn't mean that you need to be the lead of the project. It could be someone else taking that role, right? But it is important, I think, to be familiar with it, to be able to influence and work with it, right?
Thank you.
Thanks for the presentation. I have a question regarding the digital model. Did you consider to open it to, let's say, some kind of virtual world like metaverse, so you could see how more people interact with it, not only the people from the questionnaire, but broad public?
So what I've done is not a questionnaire. It's semi-structured interviews. So it's more qualitative methods instead of quantitative. So the questionnaire wouldn't really serve the purpose what I was looking for, because what I wanted to get out was actually look at the different ways conversation could go as well in the interviews. So no, I haven't done questionnaires, though I know there's questionnaires already done by NTNU throughout the courses. So there's evaluation of the courses going on as well. What I'm trying to look at is more from a critical perspective of how this framework is affecting the way we work.
Yes, but honestly, it will not be question, because I would like to say that you said you will try to wake us up.
Did I make you sleep?
No. I just want to say, in my personal opinion, your presentation was the most powerful presentation today. It was better than coffee, and I would like to thank you.
Oh, thank you so much.
Okay, thank you very much. So, as I said, we are finishing the first day of the conference. Thank you very much for all the presentations of today, and thank you for the people in the audience. So I'm thanking myself too, but first I'm thanking you. Yeah. So, do you know where we have a dinner? Because I don't remember exactly if I sent, but I sent an email with a link to the location. I hope you got it. The restaurant is kwestia czasu, the question of time, but I hope you have it, yeah? Yeah. Yeah, it's a road from the faculty, yes? Henry, I know that there was some difficulty with my mails coming to you or not. No? So, we shall meet there at about 7. Yeah? Okay? So please enter there, and then we will find you. Okay. Thank you very much.